So hello everyone, welcome to IMS GATE Academy guys. So how are you guys? Are you ready to rock guys? Yeah. So in this GATE booster session, I am here to take a very important subject for electrical EC and instrumentation guys, which is network theory guys. Okay. So in this network theory, we'll take two session. Okay. So in this two session, today we'll take two subject. In this subject, we'll take two chapter. So first one is basics of network theory. Okay. And second one is the network theorems guys. Okay. And as you know, this subject, which is network theory, is very important for electrical EC and instrumentation guys. Okay. And as for GATE exam, as you know, the weightage of this subject is very high, sir. Okay na, which is 10 to 12 marks. Okay na. And if you are very good in basics of network theory, then by just giving very less effort, you can get very good marks guys. Okay na. So we'll do here and we'll discuss all the concepts guys by just doing all the problems guys. Okay na. So we'll deal all the concepts via problem only. Okay na. Is it okay? Yeah, na? So let us start this session by this problem guys. Okay. So let us start this session with this problem. Okay. So for every problem, I will give you some time. Okay. And you have to just try to solve this problem. Okay. And if you are getting problem, then I will discuss in very detailed manner guys. Okay na. So first of all, you try guys. Okay. So for this question, I am giving you some time guys. Okay. So just try. Yeah. So just try to solve this question in 1 minute guys. Okay. So I am giving you 1 minute for this question, and this is very sufficient to solve this question guys, because it is very easy question guys. Do it fast please. Good evening all of you. So do it fast please. 20 seconds remaining. Do it fast please guys. Okay. So only 8 seconds is remaining guys. Do it fast please. Okay. So time up guys. Okay na. So how many of you got the correct answer guys? Just tell me please. Okay. So yeah, someone is saying B and A. Okay. So let us see guys. Okay na. So what we have to find here, just see the question please. So it is given in the circuit shown below, the voltage and current source are ideal. So it is given the voltage and current source are ideal guys. Okay na. So this voltage source and this current source are ideal. Now we have to calculate the voltage V out across the current source in volts is. Okay na. So just we have to calculate this voltage guys, which is across the this 5 ampere current source. Okay. So this is very easy question. Okay. So Piyush is saying option A. So let us take Piyush. Okay. So what we can do here guys, just okay. So here this current is how much? So this current is 5 ampere. Is it okay now? Yeah. So this current is 5 ampere. And if this current is 5 ampere, what about this guys? What about this current? So as you know, this is open circuited, and in open circuit case, there will be zero current guys. Okay na? So all these 5 ampere current will flow through this 2 ohm resistor only. Is it clear? Yes or no? Is it clear to all? Yes or no? Respond please. Okay. Now what we have to do, as we have to find V output. So what we can do guys, as we know, we can't apply voltage or we can say we can't apply KVL in this loop guys. Why? because we don't know about this voltage. Actually we have to calculate this voltage only, okay na. And second is, if I just want to write KVL in this mesh also, we can't, okay na, because you have to calculate this voltage voltage across this 5 ampere current source also, guys, okay na. So what we can do here, so we can find by using current division, okay na, or we can say current distribution. So current distribution, by current distribution, what we can say, as this is 5 ampere and this is 2 ohm resistance, so voltage drop across this is how much, guys? So this is 5 into 2, which is 10 volt. Is it clear to all, yes or no? Okay. So now what I'm doing, is, yeah, so what I'm doing is, as we know, in this loop we know all the voltages, guys, as we have to find V output. This voltage is 10 volt and this voltage is 10 volt. So all the voltage across all the elements, as we know, so we can write here KVL, guys. So write KVL simply. So by writing KVL, what we can write, so this is nothing but minus of V output plus of, what is this, guys? So this is plus of 10 and this is plus of 10 and the summation is equal to 0. So simply I am applying here KVL. Is it okay now? Yeah. Okay. So what is the V output, guys? So now from here we can say V output is nothing but 20 volts, guys. So this is the very, very simple question, guys. Is it clear, yes or no? So this is the very, very simple question. Okay. And yeah, so the option C is correct. So many of you giving the correct option also. Okay. Yeah. Very good, guys. Okay. Is it clear to all, yes or no? Shall we move on the next problem, guys? Okay, very good. So let us move on the next problem. So just try to find this, guys. Again, this is very good question, guys. Very good and basic question only. Okay, do it fast, please. Do it fast, please. Do it fast, please. Do it fast, please, guys. Do it fast, please. So initially we have taken all the basic question. Okay, as we know, many of you are getting difficulty in basic concepts only, guys. Okay na? Or yadi network theorem, in network theory, if you are very good in basics, then you can solve any problem, guys. Okay na? Any problem. That's why I'm just dealing with the very basic terms. Okay. Just try to find this. Okay. So Krishna is saying A. Okay. Let us see, guys. Okay, let us see. Do it fast, please. Okay, Atul is saying A. Very good. Okay. Okay, so let us see, guys. Okay, so again, here what we have to find. So it is given for the circuits on in the figure, the current I is given by. So for this circuit, we have to calculate this current I, guys. Okay, now. So how to calculate this current, guys? Okay. So we can solve this problem by many method. You can find this current by many method, guys. We can apply what? We can apply mesh analysis. Okay, now suppose I am considering this current is I1, this current is, okay, yeah. So I'm just changing the color. Okay, yeah. So this current is I2, this current is I3, and by solving these three equation, you can get the value of I also. Is it clear? Okay. Or you can apply node analysis. Here you can apply node analysis. Or what you can do? You can do current division also. You can do current division also. Okay, na? So we have many method to solve this problem, guys. But what we have to learn here, so simply we have to learn this, ki how easily this problem can be solved, guys. Okay, and this is the very, very important things we have to learn in this network session, guys, network theory session. Is it clear now? Okay, yeah. So how to solve this problem? By very easy method, guys. Okay now. So simply what we can do, so as we know this current is what, guys? As we know this current is nothing but voltage drop across this 2 ohm resistor and divided by this resistance only. So as we know this current is nothing but voltage divided by resistance, so just we have to calculate what, guys? So just we have to calculate voltage across 2 ohm resistance only. And as you can see from here, guys, this voltage, this 3 voltage is nothing but the voltage of this node terminal, because I am just taking this is as a reference, guys. Is it clear now? Okay. So now as you know this voltage is 3 volt, this node voltage is 3 volt, so just we have to calculate this voltage. Is it okay now? So to find this voltage, what we can do? What we can do, guys? So just apply nodal analysis, guys, here. Okay. So let us suppose this voltage is V of X. Okay. And if it is V of X, then apply node analysis at this point, guys. Okay now. So how to apply node analysis? What is node analysis? All of you know. Okay now. So it is nothing but KCL, guys. It is nothing but KCL and Ohm's law. Okay now. So sum of the current you have to calculate here, and the total incoming current should be equal to total outgoing current. Just we have to do that. Okay now. Just we have to do this, guys. Okay. So let us do this. What is this? So this is 6 ampere current. Okay. Very good. This current is I, and as we know, as we don't know actually the current of this terminal, so let us suppose this is any current, I of 1 or I dash, anything you can assume. Okay now. So I am assuming I1. Okay. So let us write what? KCL at node Vx, guys. Okay. So here I am writing write KCL at node V of X. Is it clear? So what will be the value, guys? What will be the value of KCL at the Vx? So the incoming current is how much, guys? Incoming current is 6 ampere. Incoming current is 6 ampere. And what about outgoing current? Outgoing current is I and I1. So what we can write here? So simply we can write this is nothing but 6 is equal to I plus I1. Okay. So I'm writing here 6 is equal to I plus of I1, guys. Is it clear now? What about I and I1? So here again we can see, as we know, I is what? Voltage divided by resistance. This node voltage is how much? So this is Vx, and this node voltage is the what? 0, which is grounded. So this is Vx minus 0 divided by 1. So this is Vx, guys. Okay. So here I am writing 6 is equal to, so this is I1. So for I1 I am writing Vx minus of 0 divided by 1. So plus for I, what we can write? Vx minus 3 divided by 2, guys. So this is Vx minus of 3 divided by 2. Is it clear to all? Okay. So now what we can do, guys? So just take LCM. Okay now. So this is what? So this is 2Vx plus of V of X minus of what, guys? 3, and this is equal to 6. Is it clear? Yes or no? Okay. Very good. Very good, guys. So let us see what we can write here. So this is nothing but 12, and this 12 is equal to 3 times V of X minus of 3, and from here what we can write? So this is 12 plus 3, 15, and this is equal to 3Vx, guys. Okay. So now what we can write? So from here we can say, therefore V of X is equal to how much, guys? So this is 15 by 3, which is equal to 5 volts, guys. Is it clear? Yes or no? Is it correct? Yes or no? Just respond, please. Is it clear to all? Yes or no? Respond, please. Okay. So now as we know the Vx is equal to 5 volts. So now what we can say, so as Vx is equal to 5 volt, so we can write I is equal to Vx minus of 3 and this divided by resistance of the resistor which is 2 ohm. So therefore I is equal to, as V of x is how much guys? Sorry, Vx is how much? 5 volt. Okay, so this is 5 minus of 3 and this divided by 2, so this is 1 ampere guys. So this is 1 ampere. So here I is equal to 1 ampere and this is the correct answer. And this is the correct answer. Okay, so many of you got the correct answer guys. Very good, very good. Okay, so this is also a very good question and very basic questions guys. Okay now, is it clear to all? Yes or no? Okay, so फटाफट like कर दो बंदो, do it fast. Okay, so let us move to the next problem guys. Okay, so just try to solve this problem. This is very good question guys. Okay, and for this question 90 seconds is very sufficient guys. Okay, so just take 1 minute 18 seconds sir. It's very easy question. Do it fast please. Do it fast please. Okay, do it fast please guys. 25 seconds is remaining. Do it fast please. Okay, so very good. So do it fast. Someone Atul is saying B. Okay, yeah, just try to give the answer guys. Okay, so time up guys. Yeah, so still 6 seconds is remaining. Do it fast please. Okay, so time's up. Okay guys. Okay, so many of you are giving answer. Okay, so let us see which is the correct answer guys. Okay, so first of all we should learn here how to approach this type of question guys. Okay now, so let's just try to find the way by which we can solve this type of questions guys. Okay, so Krishna is saying D. Okay, so let us see Krishna. Okay, so what we can write here, so simply what we have to calculate guys, so for the following network we have to find the value of I1 plus I2. What is I1? What is I1 here? So the I1 is the current through this 3 ohm resistor guys, and I2, so this is not I4, this is I2, and this I2 is the current through these 3 ohm resistor guys. Okay, and for the given circuit what we have actually, so we have a 20 ampere current source, and again we have a 20 ampere current source which is connected in parallel with what guys? This 20 ampere, sorry. Okay now, so Rohit is saying D. Okay, so let us see Rohit. Okay now, so how to solve this question guys? So first of all tell me how to solve this question. Okay now, how to solve this question guys? Okay, so what we can do here guys, so just see here what we can do here, so what we can do here, can I find R equivalent here? Yes or no? And similarly, can we find R equivalent here also guys? Is it correct? Yes or no? Is it correct? Yes or no? Okay ना, क्योंकि यदि आपने R equivalent find, if you find the value of R equivalent, then you know the value of this current I1, and this, suppose this is not I1, I'm just considering this is Ix, and this current is Iy, because we have to calculate only I1 and I2. Is it now? So let us suppose this current is I of x and this current is I of y. Then if you know the value of Ix, so by the what guys? current division we can find the value of I1 and I2 guys. Okay now, is it clear, yes or no? Is it clear, Rohit? Yes or no? Okay, so let us find guys. So what is the value of R equivalent? Just tell me please. So here what we can see, so we can see here 3 resistors are connected in parallel, and when the resistors are connected in parallel, what we can write guys, so we can write 1 by R equivalent is equal to 1 by 3 plus of 1 by 3 plus of 1 by 3. Is it clear now? Very good, very good. So what we can write, so from here we can write guys, this is nothing but 3 and this one is 3. So from here we can say R equivalent is equal to 1 ohm. Is it clear to all, yes or no? Is it clear to all, yes or no? Similarly, can we write this R equivalent is 1 ohm, yes or no? Similarly, can we write this R equivalent is 1 ohm, yes or no? Respond please. Okay now, very good. And as we know, the value of R equivalent is 1 ohm and this is also 1 ohm. Just tell me about this guys, about this. What is this? So this is the net current. Actually there is 2 current which is connected in a parallel guys. Okay now, there is 2 current source which is connected in a parallel. That's why I just want to draw this network by just a single source guys, by a single source only. Okay now, so let us try to do. Okay, so as I want to know the current at this point guys, so can we apply KCL here? Is it correct? Can we apply KCL here na? So what is the value of KCL? So here I am writing, suppose this current is 20 ampere, this is the incoming current, this is the incoming current which is again 20 ampere, and this is equal to outgoing current which is Ix plus of Iy guys. Is it clear? So what we can write, so we can write 4, है ना? So here, sorry, so here what we can write, I am writing here, so this is 40 is equal to I of x plus of Iy guys. Is it clear now? So this current should be equal to 40 ampere. Is it clear now? So I am just drawing this network again. Okay now, so this is what, sorry, yeah, so this is what guys, so this is 1 ohm resistor, this is 1 ohm resistor, and this is 40 ampere of current source. Okay now, so let us draw this network again. So here I am drawing, so this is a resistance of 1 ohm, again this is a resistance of 1 ohm guys. So the value of this resistance is 1 ohm, so this is 1 ohm, and the current of this current source is how much guys? So this is 40 ampere. Is it clear to all, yes or no? Respond please. Is it clear to all, yes or no? Respond please. Okay, very good. Okay, so now what we can say, so we can say here sir, what, as this current is what, 40 ampere, and this resistance is 1 ohm and this resistance is also 1 ohm, so this current will divide equally in these 2 resistors guys. So this is what, so this is 20 ampere and again this is 20 ampere guys. Okay now, so what is this 20 ampere? What is this 20 ampere guys? So this is nothing but Ix and this is nothing but Iy. Okay now, and as you know the value of Ix and Iy, so by what guys, current division only we can find the value of what guys, we can find the value of I1 and I2. Is it clear now? So what is the value of I1 guys? So we can write here I1 is what, so by current division we can write total incoming current which is Ix. What we have to find, current here only now, so this is into 1 by 3 divided by 1 by R equivalent which is 1 by 3 plus of 1 by 3 plus of 1 by 3 guys. Is it clear? Is it clear, yes or no? Okay, very good guys. So let us see here, Ix is how much guys? So Ix is 20. So this is 20 into 1 by 3, this divided by 3 and by 3. So this is what guys? Okay, so this is 3 and this divided by, because this is LCM is 3 now, and so this will be 1. So this is nothing but 20 by 3, guys. So this is nothing but 20 by 3. So the value of I1 is 20 by 3. Okay. So here I'm writing the value of I1 is equal to 20 by 3 ampere, guys. 20 by 3 ampere. Can you please tell me what about I2, guys? I2 value is what? Is it same or yes or no? It will be same now. Okay, very good. So we can write here again. So this I2 is equal to 20 by 3 amps. Okay. So from 1 and 2 we can write I1 plus I2, which is equal to 20 by 3 plus of 20 by 3, which is nothing but 40 by 6. Oh, sorry, 40 by 3, guys. And this is the correct answer. Okay. So which option is correct, guys? Which option is correct? Just tell me, please. Spawn, please. Which option is correct? 40 by 3 is how much, guys? Just tell me, please. Okay. Do it fast, please. Which option is correct? So obviously the option D is correct, 13.33. Very good. So many of you, Rohit, Krishna, D is correct. Saurav, very good, guys. Very good, guys. Okay now? Very good. So let us try this question, guys. Let us try this question, guys. Again, this is a very good question, guys. Again, this is a very good problem. Just try to do this. Try to do this, guys. Do it fast, please. Do it fast, please. Do it fast. Do it fast, please. Okay. So what is the correct answer, guys? What is the correct answer? Rohit, Krishna, just tell me, all of you, just tell me, please. What is the correct answer? Okay. This is very good question, guys. Just try to find this. Just try to solve this, guys. Okay. So let us see, guys. Okay now. So let us see how to solve this type of question. Okay now. So here, what we have to calculate, just see first. So what is given? Consider the circuit shown in figure. The voltage VXD is what? So what we have to calculate here? What we have to calculate here, guys? So we have to calculate the value of VXD, guys. VXD. So in this network, what is VXD? So Krishna is saying D. Okay, Krishna, just let us see. Okay, and I think you are doing some mistake. Okay, so let us see here, or just check your calculation, Krishna. Just check your calculation or see here. Okay now. So what we have to do here? So we have to calculate VXD. So first of all, we should know what is the meaning of VXD. So VXD is the voltage drop across Vx and Vd. It means that just you have to start at X and go to, okay, just you have to start at X. You have to start at X and go to what, guys? Sorry, yeah. So go to D. Just you have to do this. You have to do this. Okay now. So how to do this, guys? So first of all, we should know, as we know, this is the node voltage now. And as I have told many times, guys, the node voltage is always defined with respect to ground. And if I'm talking about what, guys? Branch voltage. So there is actually there are many difference between the branch voltage and node voltage, guys. Okay na? So just we have to understand this concept, guys. Otherwise you will get wrong answer always. You will get always wrong answer, guys. Okay na? So what is this? So this is the node voltage only, and node voltage is always defined with respect to ground. Okay na? So what is ground? This. So this voltage is nothing but Vx. What about this, guys? So this is again a node voltage, so it will be defined with respect to ground. So this is nothing but Vd, guys. Is it clear? So now what we have to do, we have to take a loop, guys. Okay na? Just we have to select a loop, because we have a loop na, we have a closed path na. This is from ground to ground. Is it correct na? So what we can do, so we have to just write a KVL. Just we have to write the KVL. But here we have a problem, guys. What we have? So while writing KVL, we should know the voltage across all the elements, which is the part of this loop, guys. Is it clear now? So first we have to calculate the voltage drop across these 2 ohm resistors, 2 ohm resistors and 5 ohm resistors. Okay na? So to find the voltage drop, what we can do, guys? So just we have to write KVL here also and here also. Okay na? So I am considering this is as loop 1, so as it is L1 and this is L2, guys. Okay na? So you can take any direction. Okay, so I am considering this direction. Okay na? So this is L2. So what is L1, guys? Okay, so here I am writing KVL. So write KVL in loop 1, guys. Loop 1. So what is the value of KVL, guys? What is the value of KVL? Okay, so for loop 1 I am writing, so this is what, guys? So this is minus of 10. Okay, so here I am selecting a different color, which is, yeah, okay, so this one is, yeah, so this is what? Minus of 10. So this is what? So this is, so let us suppose this current is I1. Okay na? Yeah, and this current is I2. So what is this? So this is minus of 10, so plus of 5 times I1 plus of, what is this? So this is 3 times I1, and this is what? This is 2, so this is 2 times I1, and this must be equal to 0, guys. This must be equal to 0. Okay, so Krishna is saying C. Okay, yeah, it's correct. Very good, Krishna. Okay na? So what is the value, guys? So from here we can find the value of I1. So this is what? 5 plus 3, 8 plus 2, 10. So this is 10 times I1 is equal to 10. So therefore I1 is equal to 1 ampere, guys. So this is very correct for this loop, guys. Okay na? So from here we can say the current which is flowing through this element or through this loop is 1 ampere, guys. And if the current is 1 ampere and the direction of this current is this, so we can say there must be a voltage drop across this 2 ohm. So this is the entering direction. So as we know, the resistance is always absorbing power. It means that this will be the positive terminal and this will be the negative terminal, guys. And let us suppose this voltage is V1. Let us suppose this voltage is V1. Okay, so now what we can write here? So again we'll write, so therefore V1 is how much, guys? So V1 is 2 into I1, so this is 2 into I1 is 1, so therefore 2 volts. So therefore it is 2 volts. Is it clear to all, yes or no? Is it clear to all, yes or no? Okay, very good. Now similarly we can find the value of what, guys? I2 also. Okay na? So let us find the value of I2. So what is I2, guys? So this is, okay, sorry, yeah. So I'm adding one page here. Okay, yeah. So write KVL in loop 2, guys. Loop 2, or you can write mesh 2. Is it clear now? So what is the value? So this is minus of 20 plus 5 plus 10. So this is minus 20 plus 10 I2, guys. Okay, so this is minus of 20 plus of 10 times I2, and this is equal to 0. So from here we can say guys 10 times I2 is equal to 20. So therefore I2 is how much? I2 is equal to 2 ampere guys. Okay, and if it is clear to all, then again we'll write value of V2 guys. So again we'll write what? We'll write the value of V2. So therefore we can write V2 is equal to what guys? So what is the value of this resistance? So the direction of this current is, the direction of current I2 is this. So this is plus and this is minus, and the value of this is V2. Is it clear? So what is the value of this? So this is what? 5 into I2 guys. So let us write this is 5 into I2, which is 2, is equal to 10 volts guys, which is equal to 10 volts. Okay now? Is it clear? Very good. Good evening Nikhil. Okay, so now what we have to do guys? So as we know, just see the question. As we know the value of V1, value of V2, Vx, Vd, 5 volt, all things we know. But we have to find one more thing guys, and it is very, very important. That's the thing we should understand for this question guys, for this type of question guys. Okay now? So just tell me one thing here guys. Just tell me one thing. What is the value of this current guys? If this current is I, can you please tell me the value of this current? Rohit, just tell me please. Just tell me the value of this current. What is the value of this current guys? 0. Very good. Very good. This type of questions is asked in GATE many times guys. If you can see, if you have seen guys, in previous year also there are questions of this type of, in which the current is 0 directly. Okay now? So it is 0. Why 0? Why 0? Because there are certain rules for rules of what guys? For current flowing. What are the rules guys? What are the rules? So there are basically 3 rules guys to flow the current through any elements across any loop guys. What? First rule is what? So first rule is the circuit must be closed. Okay na? Or we can say there should be a closed path guys. If there is no any closed path, so directly we can say what? The current should be equal to 0. Is it clear? So this is the first rule. What is the second rule? Okay na? So we can say if you are going to find current through any element, then there should be a voltage difference guys. Is it clear now? And if there is no any voltage difference, then there will be no current guys, or we can say 0 current. Is it clear now? So that will be the, that is the what? That is the second rule guys. And what about the third rule? Many of students don't know the third rule. What is this? So this is nothing but the, in any branch, if you want to find current in any branch, or we can say simply ki there should be a returning path guys. Otherwise what will happen? Violation of KCL guys. Violation of KCL. Just see here. Okay na? Just see here. Try to find KCL. Okay na? So there is, if there is incoming current, there should be outgoing current also, because यहाँ से क्या हो रहा है जी? Here I2 is coming, I2 is going. Okay na? So what will happen to this current guys? This should be equal to 0. Otherwise there is a violation of KCL at this node guys. Is it clear na? Which is not acceptable guys. Is it clear? Okay, so simply we can say this current should be equal to 0, and if this current should be equal to 0, so then the voltage drop across this 2 ohm resistor should be equal to 0. Is it clear? Now we can write KVL directly here guys. KVL, right? We can write KVL directly here. What is the value of KVL now? What is the value of KVL now? Can you please tell me? Can you please tell me? So this is minus of Vx plus of, minus of V1, 0, plus of 5, plus of V2, plus of Vd. Is it clear now? Or we have to calculate Vxd actually. Okay, so here I am writing again, write KVL guys. So what is KVL? Okay, So just I am writing here, KVL is nothing but minus of Vx minus of V1. So this is minus of V of x minus of V1 plus of 0. Is it correct now? So this is plus of 0 plus of 5 plus of V2. So this is plus of 0 plus of 5 plus of V2, and this is plus of what, guys? So this is plus of Vd, and this is equal to 0. Plus of Vd, and this is equal to 0. Is it clear? So here we have to calculate what? Vx minus of Vd, guys. So I'm just taking Vx and Vd here. Okay. So this will be what? So this will be 5 plus of, okay, V2 minus of V1. So right here, so this is 5 plus of V2 is how much, guys? So V2 is 10. And what about V1? So we have calculated there. What, guys? V1 is how much? 2 volts. Okay, now? So this is 2 volts. So this is minus of 2. So this is 15 minus of 2, which is nothing but 13 volts, guys. So the voltage Vxd is nothing but 13 volts, guys. So this is nothing but 13 volts. Is it clear to all? Yes or no? Is it clear? Yes or no? Okay. Is it clear? Yes or no? Respond, please, guys. Is it clear? Yes or no? Respond, please. Is it clear? Yes or no? Very good. Very good, Rohit. Very good. Okay, na? Okay, सारा कुछ होगा रुपेश. Okay, so just see here. Okay, na? So here I'm doing network theory. So just try to learn network theory. Okay, na? है ना? So network पढ़ते हैं हम लोग अभी. Okay, so let us try this question, guys. Let us try this question, guys. Again, this is a very good question, guys. Again, this is the very good question. Do it fast, please. Do it fast, please. Do it fast, please. Do it fast. So this is the N80 type question, guys. We'll do all the things, Rupesh. Okay, just wait. Okay, one by one all the concept will be covered here. Okay, now. Do it fast, please. So in this problem, what we have to calculate, guys? What we have to calculate? So consider the following. So consider the following circuit. Okay. So for this circuit, what we have to calculate, guys? The value of current I is. Okay, now. So we have to calculate this current I. This current I we have to calculate. Okay, now. So to find this current, what we, okay, so how to find this current, guys? Just tell me, please. First of all, tell me how to find this current or what approach we should apply here. Okay, just tell me, please. Just tell me, please. It's a very simple and very good question, guys. It's very simple and very good question. Okay, just you have to calculate this current, and you have given 2 volt source here, 6 volt source here, and 1 volt source here, guys. Okay, KVL. So Krishna is saying KVL. Okay. Okay, Krishna. So by KVL, how to find? By using KVL, how to find this value? Just tell me, please. Okay. So let us see. Let us see, guys. Okay, now. So what we can do, as we know, the current is nothing but voltage drop across this resistance divided by this resistance only. Is it clear now? Okay. No need to do this, guys. Rohit, why we apply star to delta conversion here? Okay na? So just we have to calculate current here na. Just we have to calculate this current only. So okay na? So if it is V1, suppose I'm taking this is V1, or we can write V of X. So what this current is, so this current will be nothing but, so this is 2 minus of Vx, and this divided by how much? So this divided by 4. Is it clear now? So just we have to calculate exactly, very good Rupesh. Okay na? So just we have to calculate what? We have to calculate this value of Vx. Okay, so how to find this value, guys? So by just applying what? We applying nodal analysis, guys. So here I'm writing, so write KCL at node V of X. Is it clear? Is it clear? Okay, so let us suppose, as this current is I, let us suppose this current N1, and let us suppose this is I1 and this is I2. Okay, so what we can write here? So we can write simply I is equal to what, guys? So this is outgoing current, which is I1 plus of I2, guys. Okay, so what is I? I is nothing but 2 minus of Vx, and this divided by what? 4. And this is equal to I1 is how much, guys? So this is V of X minus of what, guys? Minus of 6, and this divided by 8. Okay, and plus what is this? So this is V of X minus of 1, and this divided by 2. Is it clear? So let us take LCM here. So this is 8. So V of X minus of 6 plus of 4Vx minus of what, guys? 4, and this is equal to 2 times Vx by 4. Is it clear? है ना जी? अब देखो तो ये 4 इस 8 को मार देगा जी 2 times में. Is it clear now? So this will cancel by 2 times. Okay, in 2 times. So what we can write here? We can write, what we can write, guys? So this is 4 minus of, what is this? So this is 2 times of Vx is equal to, so this is 5 times of Vx minus of 10, guys. Is it clear now? Is it correct? Yes or no? Yeah. So here what we can write? So this is what? 14 is equal to 5 plus 2, 7 times of Vx, guys. So here we can say V of X is equal to how much? So this is 2 volts only. So this is 2 volts only. Is it clear? So this is nothing but 2 volts. This is nothing but 2 volts. And as it is 2 volts and this is also 2 volts, so we have to find current through this 4 ohm resistor. So what will be this, guys? 0. Very good. Very good, Smith. Okay now? So this current I is equal to what, guys? 2 minus of 2, and this divided by 4, which is equal to 0 ampere, guys. So 0 is the correct answer. 0 is the correct answer, guys. Very good. Very good, Mevada. Is it clear to all? Yes or no? Is it clear, Rohit? Yes or no? Okay. Very good. Okay. So shall we move on the next problem? Shall we move on the next problem, guys? Just tell me, please. Okay. Very good. Very good, Krishna. Okay. So let us try this problem, guys. Again, this is the very basic question. Okay. Will increase the level by 1, guys. Okay na? As I've told earlier, कि many of you are doing mistakes in this type of questions, guys. Okay ना? आप for granted ले लेते हो इसे कि मेरे से तो हो ही जाएगा. Okay ना? It is not like that, guys. हमें ultimately आंसर करेक्ट करने हैं, मार्क्स अच्छे करने हैं. ओके ना? सो आपको जो क्वेश्चन मिल रहा है उसे करेक्ट वे में करना है. जस्ट वी हैव टू solve all the problems with very accuracy, guys. Is it clear na? And we are learning here the same only. Is it clear? है ना? अच्छे क्वेश्चंस में लेवल भी बढ़ाएंगे हम लोग, बहुत अच्छे लेवल तक जाएंगे. ओके, सो लेट अस सी वन बाय वन. लेट अस सी वन बाय वन ओनली. Okay now, just try to do this please. Just try to do this guys. Do it fast please. Do it fast please. Do it fast. Why are you taking this much time guys? Yeah, so Rupesh is saying 2 what? Remaining all, just tell me please. Okay, yeah, so let us see guys. Okay now, so what we have to do, what we have to find here, just see what is given to you guys. So for the circuit given in the figure below, the power delivered by the 2 volt, so the 2 volt source is given by, okay now. So just we have to find what power this 2 volt is delivering to this network guys, okay now. So power delivering means what? When any source is delivering power, when any source is delivering power guys, है ना, कब हमारा इन्वर्टर पावर को डिलीवर कर रहा होता है? जब हम लोग उस पर लोड, मतलब वहां से जब करंट निकल रहा होता है, ओके ना. सो पॉजिटिव टर्मिनल से हमारा करंट बाहर होना चाहिए जी. देयर शुड बी आउट गोइंग करंट गाइस. इज इट क्लियर ना? या वेरी गुड. Okay, so Krishna is saying A. Okay, let us see Krishna. Okay, so which is the correct answer? Let us see. I'm solving. Okay now. So just I'm assuming this is the current I. Okay, and if this is the current I, then now we can write, as we have to find what power delivered by this 2 volt. So we can say power delivered by this 2 volt source is nothing but this 2 volt into I guys. This 2 volt into I. Is it clear, yes or no? Is it clear, yes or no? Now our task is what? Our task is to find this I only. Is it clear now? है ना? Just try to simplify question guys. Just try to make question simple. Is it clear now? Okay now? So how to make question simple? We are doing. We are just learning here. Okay now? We are learning the same only here. Is it clear now? So what we can write as this is I. And what is this guys? What is this? So this is the 1 ampere current guys. So this will be what? 1 ampere, and this is I. So if you apply again KCL here, so this current will be what guys? So this current will be I plus of 1. I plus of 1. Is it clear now? Is it clear now? Yeah, exactly. Rupesh, you are saying the same only. Okay na? Ki when the power is delivered by the source, when the power is leaving from the positive terminal, it means that the source is delivering power guys. When the power is entering into the positive terminal, it means that power is absorbed by that source guys. Is it clear to all, yes or no? Is it clear na? So the same thing you can say for negative terminal also. Okay na? So as Rupesh is saying, current enter in negative terminal means power is delivered. Exactly same, because when the current is entering into negative terminal, it means that the current is leaving to the positive terminal guys, leaving the positive terminals only. Is it clear to all, yes or no? Is it clear now? So now as we know, this current is nothing but I plus 1. Okay now? So can we apply what guys? KVL here. Is it clear now? Okay, so here I am writing what? So write KVL. Write KVL guys. So what will be the value of KVL? Just respond please. How to write this KVL? Okay, so this KVL is nothing but, so this is minus of 2 plus of what? So this is plus of 1 into the current, which is what guys? 1 plus I. And this must be equal to 0. And this must be equal to 0. So what is this? So this is minus of 2 plus of 1 plus of I, and this is equal to 0. So from here we can write guys I, which is equal to 2 minus 1, which is 1 ampere guys. Is it clear? Is it clear, yes or no? and when this current is positive of 1 ampere, it means that this value will be 2 into 1, which is 2, and the unit of power is watt, so this is 2 watt, guys. Is it clear, yes or no? Is it clear, yes or no? So this is 2 watt. Okay, so what is the correct answer, guys? Is it -2? And just tell me please, what is the meaning of this -2, guys? Just tell me please, anyone, just tell me please, what is the meaning of -2 here? What this negative signifies, guys? Just tell me please, just respond please, respond please. Not supply, yeah, very good, Smith, very good. Absorbing power, very good. Okay na? So what the delivering, because it is giving delivering power, so delivering power should be positive, and if delivering power is positive, it means absorbing power should be negative. Is it clear na? Is it clear na? So the correct answer is what? So the correct answer is positive of 2, which is 2 watt, guys. Okay na? Yeah, very good, Rupesh. Power absorbed should plus power delivered should be equal to 0. Exactly, very good. Is it clear to all, yes or no? Is it clear to all, yes or no? Okay na? So here in this problem, in gate paper, if they ask anything, if they ask current through this 2 ohm resistor, current power drop across this 3 ohm resistor, voltage across this 2 ohm resistor, anything, if they can ask anything, you can able to solve, you can give the answer for all type of questions, guys. Is it now? So that type of clarity we should have for all the questions, guys, at least for network theory. Okay na? Because for network theory, in network theory, for every problem we have multiple solutions, guys. We can solve any problem by multiple method, guys. Okay na? And that type of clarity we should have, guys, and we are learning here the same only. Is it clear now? Is it clear to all, yes or no? Respond please. Okay, very good. So let us move to the next problem. Just try to find this, guys. Okay, so this is x3, this is plus minus 6, this is x4, this is x2, this is x1, and this is 1 ampere, guys. Okay, now I hope ki now it is visible to all of you. Is it visible now? Rupesh, Maba, Rohit, Krishna, just tell me please, is it visible to all, yes or no? Is it visible now? Okay, do it fast, guys. Yeah, very good, Krishna. Okay, thank you, Rupesh, very good. Okay, do it fast please. Okay, so again I'm giving you a timer. Okay, so just try to solve this question. I'm just giving you 2 minutes. Okay, 2 minutes is very sufficient for this type of question. Do it fast please. Do it fast please. Do it fast please, guys. Question is not visible. Okay, is it visible now, Rupesh? Yeah. Okay, so I'm just reading. Yeah, I'm just reading the question, guys. Just listen carefully please. Okay na? So what is this? In the interconnection zone, x2 releases 20 watt power, x3 absorbs 18 watt power. Find the power of each element. Okay na? It is the question. Okay, or you can say just you have to choose the correct option only. Just you have to choose the correct option only. Yeah, sure Tripathi ji, sure. Okay, Smith is saying B. Smith, just see once. Here I am writing something. I have written something here. It is MSQ. So time's up, guys. Okay, na? It is MSQ. Multiple selective question. Okay, so do it fast. Smith saying 5 watt absorbed. Okay, so B option is correct. Yeah. Okay, so option B. Okay, but it is multiple selective questions. Smith. Rupesh, is it visible? Now is it visible? Yes or no? Respond please. Is it visible, Rupesh? Okay, do it fast. Just try to solve this, Saurabh. Just try to solve this question. Okay. B and D. Okay. Let us see. What about others, guys? Just respond, please. Give your answer, guys. Give your answer. Saurabh is saying A, B. Rohit is saying B and D. Smith is saying B and D. Okay. Okay. Very good. So, other than C, all the answers are given by many of the students. Okay. So, let us see. Yeah. Rupesh, B and D. Let us see, guys. Let us see. Okay. Let us see. So, first of all, just try to understand this question, guys. Okay. Now, what we have to calculate. Okay. So, let us see. Okay. So, what we have, actually it is given that X2 is releasing power. X2 releases power 20 watt. Okay. Now, what is X2? So, this is releasing power means what? Delivering power. Okay. Now, so 20 watt of power is delivered by this X2 element, guys. Okay. Now, again, what we have? So, X3 absorbs 18 watt of power. Means what? X3 is absorbing 18 watt of power, guys. Okay. Now, so what is this? So, this is X3. And if it is absorbing, means the direction of current should be what, guys? The direction of current should be what? अभी हमने बताया था ना, है ना? I just told you in the previous question only कि what is the meaning of delivering power, what is the meaning of absorbing power. The direction of current is what, guys? Positive to negative. Very good, very good, very good, Smith. So the current direction should be positive to negative. It means that the current should be entering into the positive terminal, guys. Is it clear to all? Yes or no? Is it clear to all? Yes or no? Okay, na? So what we can say, let us suppose the current through the X3 terminal is nothing but I3, guys. Is it clear now? I am just assuming this current is nothing but I3. Okay, so if this current is I3 and it is given that the power through X3 is absorbing power and it is of how much, guys? 18 watt. Is it clear now? Is it clear to all? Yes or no? And this power should be what, guys? This power should be this 6 and this I3. Yes or no? Yes or no? Just respond, please. Yes or no? Just respond, please. Is it correct? Am I right? I am writing the correct only. Yes or no? Am I writing correct? Yes or no, guys? Okay, now. So what is this? So therefore, from here we can write I3, which is equal to 18 by 6 is nothing but 3 ampere, guys. Is this correct? Is this clear to all? Yes or no? Okay. So this current will be what, guys? So this current is nothing but 3 ampere. This current is nothing but 3 ampere. So again this current will be what? 3 ampere only. Very good. Very good. Okay. Now as we know, as it is given in this diagram, this current is 1 ampere. This current is 1 ampere. So can I apply KCL at this node, guys? Yes or no? Can I apply KCL at this node? Can we apply nodal analysis at that node only? Simply we can say KCL. Okay, now it is not nodal analysis, just we have to apply KCL here. Is it okay? Is it okay? Yes or no? Respond, please. Okay, now. So if we apply KCL here, so this is the outgoing current, this is the outgoing current. So what about this, guys? So there should be incoming current of the value which is equal to I3 plus 1, which is what, guys? So this is 3 plus 1, so this is nothing but 4 ampere, guys. This is nothing but 4 ampere. Is it clear, yes or no? Is it clear to all? Yes or no? Respond please, guys. Okay, and if it is 4 ampere and we have given X2 releases 20 watt of power and the direction of current is this, so it means that the polarity of this X2 should be positive because the current should be delivering from the positive terminals, guys. Is it clear now? The current should be leaving from the positive terminal. Is it clear now? So let us suppose this voltage is nothing but V2, guys. This voltage is nothing but V2. So can I find this value of voltage, guys? This value of V2, yes or no? Is it possible to find? Obviously we can find, because we know the power value, we know the current value, so obviously we can find the value of V2, guys. Okay, so let us find the value of VT. Okay, so here we know, as we know, Px2, which is what, guys? Delivering power. Is it delivering now? So delivering power, and the value of this is what? So it is, P2 is releasing power of 20 watt. So this is 20 and this is 4. So we can write here, so this is 20 watt. Okay, so this is 20 watt and this must be equal to 4 times what, guys? V2. Is it correct, yes or no? Okay, Smith. Okay, very good, very good. It's correct. Okay, B and C is correct. Very good, Smith. Okay, now, so let us see, guys. Okay, so from here what we can write? So we can write V2, and this V2 is how much, guys? So this is 20 and divided by what? 4, which is equal to 5 volts, guys. Which is equal to 5 volts. Is it clear now? So this is the 5 volts, guys. Okay, so now if this is 5 volts, okay now, so I'm just erasing this. So this is what? Plus, sorry, so this will be what? Minus now. So this will be 5 volt, guys. And if it is 5, what about X1, guys? What about V1? So this should be equal to 5 volt because these two are connected in parallel only. These two are connected in parallel only. Is it clear now? Is it clear to all? Yes or no? So from here we can simply say, sir, as this is 5 volt and the current is entering into the positive terminal, it means that power across this X1 is nothing but what, sir? This voltage which is 5 and this current which is 1. So this is 5 into 1, 5 watt. The current is 1 ampere and the voltage is 5 volt. It means that power should be 5 watts, sir. And what about type of the power, guys? What about type of the power? Is it delivering power or absorbing power? So as the current is entering into the positive terminal, it means the power is absorbed. है ना? Power absorb हो रहा है ना जी? Is it clear ना? So what we can write here? We can write power X1 is equal to what, guys? So this is 5 into 1. So this is 5 watt and the type of the power is absorbing power. Okay, so let us see the option, guys. Okay, so Pxn is 5 watt but it is delivering. No, it's not correct. What about by Px1 is 5 watt and it is absorbed? Very correct. Okay, very correct. Now we have to check all the options because it is MSQ type question, guys. This is the MSQ type questions. Okay, now, so let us see. Now we have to find Px4. Okay, so let us see, guys. To find the value of Px4, we have to calculate the value of what, guys? We have to calculate the value of voltage across this X4 element. Is it clear now? Is it clear, yes or no? So let us find. Let us find the value of this, guys. Value of this. So let us suppose this is plus minus V4. Plus minus V4. Okay. So if this is 5 volt, this is 6 volt and this is 4. So can we apply KVL here, guys? Can we apply KVL here? Yes or no? Okay. So here I am writing what? So I am writing KVL and the value of KVL is minus of 5. Okay, minus of 5 plus of 6 plus of V4 is equal to 0. Is equal to 0. So what is the value of V4 guys? So V4 will be 5 minus of 6, which is equal to minus of 1. So here we can write V4 is equal to minus 1 volts. minus 1 volts. Okay ना? Is it clear? minus 1 volts कहने का मतलब क्या है जी? So simply you can say if it is plus, it means that it should be negative and it should be positive. You have chosen what guys? A polarity of opposite polarity simply. Okay na? And if it is negative, it is positive, then you can say the value is negative, positive 1 volts only. 1 volts only. Okay na? So now what you can see guys, so the power is what? So here I am writing Px4 is nothing but 1 into 3, which is 3 watt, and the type of the power is what guys? So current is entering into the negative terminal, or you can say current is leaving to the positive terminal guys. And if it is leaving to the positive terminal, it means that the current is delivered by this V4, or we can say X4. Is it clear now? So simply we can say the current will be delivered and the value of the power is 3 watt and the type of the power is delivering power. Is it clear to all, yes or no? Is it clear to all, yes or no? Respond please. Okay, yeah. So the power is 3 watt and delivering power. It means that option C is correct. What about D option guys? So it is saying it is absorbing power. That's why it is not correct. That's why it is not correct. So this is very good question guys. Is it correct now? Very good. Very good Rupesh. Is it clear? Okay. So if anyone is solving this type of question, it means that you are very clear in power guys. You are very clear in power. Is it clear now? Because in the single question, you have to very clear about delivering power, absorbing power. Okay, yeah. Just we have to learn this only Rupesh. Just we have to learn this only. Okay ना? है ना? हर चीज को मेंटेन रखना है जी, सिर्फ स्पीड नहीं बढ़ाना है, स्पीड के साथ लेंथ को भी रखना है ना? तभी जाके विकेट में लगेगा बॉल. ओके ओके, कोई नहीं. सो हम लोगों ने क्या कहा जी? व्हाट वी कैन से हियर? सो द आंसर इज बी एंड सी. ओके, इज इट क्लियर? वेरी गुड सौरभ सर, very good. Okay, so let us try this problem guys. Just try to find this problem. Again, this is a very good question guys, and for this question again I am giving you 2 minutes guys. Again I am giving you 2 minutes, or you can take 3 minutes also. Okay, so because this is a very good question, again this is a very good question. Okay na? So do it fast please, do it fast. 3 minutes is more than sufficient. 3 minutes is more than sufficient. Do it fast. Just try to find this Saurabh. Try to solve this. Thank you. Okay. So do it fast guys. Do it fast please guys. 2 minutes is remaining. Do it fast please. Do it fast. Do it fast guys. Do it fast. Take your time. Okay. Very good Ankit, very good. That type of in spirit we should have guys. Okay. Do it fast, please. Okay, do it fast. Yeah, so time's up, guys. Okay, so how many of you got the correct answer, guys? Just tell me, please. How many of you got the correct answer? Just respond, please. Respond, please. Okay, yeah. So let us see, guys. Okay, now what we have to calculate here. First of all, tell this. Okay, now. So what we have to calculate? So just it is given to you for the circuit shown in figure. The current I of X is given by what? Okay, now. So you have 4 options. It means that you have this is the MCQ type. Okay, now it is not given. It means that it is MCQ type. Okay. So how to calculate this I of X, guys? Just tell me, please. Just tell me, please. The question is what? We have to calculate the value of I of X. Okay. So again, I will tell here what, guys? There are multiple solutions, guys, for this type of question. I'm always telling you, guys, network theory is like aptitude. You can solve that problem by taking what, guys? What? By taking more time. But the important point is what? The important point is we have to calculate that problem in less time, guys, with accuracy also. Okay, now, and we have to learn this concept only. We have to learn this thing only. Is it clear to all? Okay, now. So for every problem there are multiple solutions, guys. This is the what, guys? This is the what we can say. This is about network theory. That's why I'm saying now. And network theory is nothing but aptitude. Like it is like aptitude only. You can solve the problem. If I'm giving you 5 minutes, 10 minutes, you will able to solve. Okay, now. But we don't have that much time, guys. Okay, now. So we have to solve this problem or this type of problem in such a way it is taking less time with high accuracy, guys, with high accuracy and without any error. Okay, now. So let us try to solve this question, guys. Okay, now. So how many type of solution we have actually? Okay, now what we can do here? So we can apply mesh analysis. We can apply what, guys? We can apply what? We can apply nodal analysis, or what we can do? We can do current division, guys, current distribution, guys. Is it clear to all? Yes or no? Is it clear now? So here I am doing what? I am doing current distribution, guys. By distributing the current, I will find the value of I of X, guys. Let us see how. Okay, now. So here I'm writing the current equation. So what is this? This is I of X. What is this current, guys? So this is 4 ampere. So if this is I of X and this is 4 ampere, so total incoming current should be equal to total outgoing current. Is it clear now? Okay, so this current will be I of X plus of 4. Is it clear? Is it clear, yes or no? Okay, so this is nothing but I of X plus 4. Now at this node again I want to apply KCL. Okay, now, but we don't know the value of this current, guys. So let us suppose this current is I of I, guys. Simply I'm just taking I. Okay, now. So if this is I, so it means that this will be I plus of Ix plus of what, guys? 4. I plus of Ix plus of 4. Is it clear now? Very good. Now just come to this point, guys. So again this current is 4 ampere. So this current will be, this current will be just leaving this outgoing current. So this will be what, guys? So this the remaining current will be I plus I of X. Okay, now again this current I of X is in this direction. This is the incoming current. This is the outgoing current. So the remaining current will be I only. Then the remaining current will be I. So you can see the outgoing current and incoming current are same. Okay, now it means that you are doing good. You are doing correct only. Is it correct now? So the distribution of current is correct. Is it clear? And if it is correct, now we can apply what, guys? We can apply simply KVL to find the value of current. to find the value of I of x. Is it clear to all? Yes or no? Is it clear? Yes or no? Respond please. Okay. Yeah. So just see here, guys, what we can do here. What we can do here. So I'm just doing what? I'm just doing what? So I can take KVL in this way, or an outer loop also. Okay, na? It's your choice in which way you want to write KVL, guys. Okay, na? So I'm just doing what? I'm just taking a small loop. Okay, na? So suppose this one L1, this is L1. Okay, and again, as we can see, this is the second path we have. So I'm taking this path also. I'm taking this path also, and assuming this is the loop 2 and this is the loop 1. Is it clear to all? Yes or no? Respond please. Is it clear to all? Yes or no? Respond please. Okay. So now what we can do, guys, so simply we'll write KVL. Simply we'll write KVL. Okay. So let us write KVL, guys. So here I'm writing KVL. Okay. So here I'm writing KVL. So write KVL. Okay. So what is the value of KVL, guys? So here I am writing KVL in mesh 1. Okay, na? KVL in mesh 1. Okay. So what will be the value, guys? So this is what? So this is minus of 10 plus of what? So this is plus of 2 times I plus of what, guys? 2 plus of 4 into I plus of Ix plus of 4. Okay, plus of 10 into I plus Ix. Okay, and this is equal to 0, and this is equal to 0. Is it correct? Yes or no? Is it correct? Have you got the answer, Rupesh? Have you got? Anyone just tell me? Anyone just tell me? Okay, now why are you taking this much time, guys? Okay, so just try to. Okay, so just try to solve this only. Okay, now just see here, guys. So what we have? So actually, what is this? So this is 2I plus of 4I. So this is 2 plus 4, which is 6. 6 plus of 10. So this is 16I. Okay, now what about Ix, guys? So this is 4 plus of 10. So this is 14 Ix, guys. 14 times Ix, and this is equal to, so this is 10 minus of 2, and this is minus of 16. Is it clear now? So here what we can write? We can write 16 plus 14 Ix is equal to, what is this? So this is minus of 8, guys. Is it clear now? And this is our equation 1. This is our equation 1. Okay. Now what we have to do? So we have to write KVL again, and now we are taking mesh 2, guys. We are taking loop 2. Is it clear now? Okay. So let us find. So again write KVL in mesh 2, guys. Is it clear? So what we have actually? Okay, now. So what we have actually? So in this mesh we have minus 10 plus of 2I. So here we have minus 10 plus of 2I minus what we have, guys? So this is minus of 6 into Ix plus 4. So this is minus of 6. So this is minus of 6 into Ix plus of 4. And what about next, guys? So this is plus of 4Ix plus of 4 times Ix, and next is what? So this is what? Minus of 12 times Ix. So this is minus of 12 times Ix, and what about next, guys? So this is plus of 6, and this is equal to 0. So this is plus of 6, and this is equal to 0, and this is equal to 0. Is it clear now? Is it clear? Yes or no? So again I am solving. Okay, now finding. So this is what, guys? So this is 2 times I, and this is minus of 6 plus of 4. So this is minus of 2, and this is minus of 12. So this is minus of 14. So this is minus of 14 times I of x, and this is equal to what, guys? So this is 10 minus of what, guys? So this is 10 plus of what? So this is 24, okay, and this is minus of 6. Is it clear now? So here we can write this is 2I minus of 14 times ix, and this is equal to, है ना, ये कितना हो गया जी, 34, and minus of, so this is 34 minus of 6, which is 28. Is it clear now? And this is our equation 2, and this is our equation 2. Is it clear? Now what we have to do is, so as we have two equation and two variable, so we can easily find the value of I and ix, guys. Okay now? So here I am writing from equation 1 and 2, guys. From equation 1 and 2. Is it clear, yes or no? Is it clear, yes or no? So what we can write from equation 1 and 2 here? So we can write as this is 2I minus of 14 times I of x, this is equal to 28, and in the equation 1 we have, what is this, guys? So this is 16I, okay na? So this is 16 plus 14ix, so this is 16I plus of 14 times ix, and this is equal to how much, guys? This is equal to minus of 8. So this is equal to minus of 8. So just add these two equations, guys. Okay na? So what we can say by adding, so this will be cancel out. So we have 18 times I, and this is equal to 20, guys. 18 times I is equal to 20. So therefore we can write I is equal to 20 by 18, which is nothing but 10 by 9 ampere. Is it clear to all, yes or no? Is it clear to all, yes or no? Okay. So let us see, guys. Okay now, what we can do now? What we can do now? Now, as we have this equation, the value of I actually, and we have this equation. So again, if I am assuming this is the equation 3, so we can write from equation 2 and 3. So from equation 2 and 3, what we can write? So we can write this is 2 into I, and I is what, guys? So this is 10 times 9, 10 by 9, sorry. So this is 10 by 9 minus of 14 times I of x, and this is equal to 28, guys. Okay. So just calculate this value. So this is 20 divided by 9 minus of 14 I of x, and this is equal to 28. So if I am taking this 14ix, है ना, here, so what will be? So this is 14 times I of x, and this is equal to 20 by 9 and minus of 28, guys. Okay. So just try to just solve the value of ix, guys. Just find the value of I of x. Just calculate this value only. Minus of 1.84. Breeze में KVL लगा. Yeah, it's okay. It's okay, Rupesh. What I say ना, नहीं आंसर आएगा, डेफिनेटली आंसर आएगा रुपेश, डेफिनेटली आंसर आएगा. ओके ना? जस्ट चेक, जस्ट क्रॉस चेक, और आप देखो कि वोल्टेज ड्रॉप और करंट का डिवीजन आपने सही किया नहीं किया. जस्ट यू हैव टू सी दिस. ओके ना? जस्ट यू हैव टू चेक दिस ओनली. अदरवाइज you can apply anything, guys. If you are very clear and if you are very accurate na, then always you will get correct answer only. Is it correct now? Just check once and you will find what, guys, any mistakes you have done. Okay ना? आपने कुछ ना कुछ mistake किया होगा, देखो एक बार. Okay. So just tell me the value. Yeah. So Krishna is saying minus of 1.84. Very good. Very good, Krishna. Yeah, it's totally correct. So the answer is minus of 1.84, guys. And this is the correct answer, guys. This is the correct answer. Okay. This is the correct answer. Is it clear? Yes or no? Is it clear to all? Yes or no? Respond, please. Respond, please, guys. Okay. Is it clear to all? Yes or no? Remaining all, why are you not responding, guys? Is it difficult question? Is it difficult? And if it is difficult, or if you are facing any problem while solving question, just comment guys. Just tell me your problem. I am here to solve your problem only. Okay na? Just tell me please. Do it fast guys. Okay? Yeah. Is it clear to all? Yeah, very good Rupesh. Okay na? So shall I move on to the next problem guys? Shall I move to the next problem? Yes or no? Respond please. Okay? Very good guys. Yeah. So let us try this problem guys. Let us try this problem. Again this is the very good question guys. Again this one is very good question. Okay? We'll tell you Rupesh. Yeah, just try to solve this first. Okay, now we'll tell you. Okay, do it fast please. Yeah, do it fast. So this is what guys, this is the resistance. Again this is the resistance. What is this? So this is alpha V guys. This is nothing but alpha V. This is R and this is current. And you have to calculate what? So consider the circuit as shown below, which has a voltage dependent voltage source. The value of I2 by I1 is. Now you have to calculate. Now you have to calculate what guys? Just you have to calculate I2 by I1 ratio. You have to calculate the ratio of I1 by I2. Just do it fast please. For this question, again I am giving you 2 minute answer guys. Sorry, 2 minute guys. Okay now? So just try to find the answer, okay, in this 2 minute guys. Okay, and this 2 minute is very sufficient for this type of question guys. Do it fast please. Do it fast please. Sorry. Do it fast please. Do it fast please. Do it fast please guys. 28 seconds is remaining. Just do it fast. Okay, so time's up. Okay, yeah, so time's up guys. Time's up guys. How many of you got the correct answer please? Just tell me please. How many of you got the correct answer? Just respond please. Okay, yeah, so let us see guys. Okay, so how to solve this type of questions? Just see once. Okay now, so actually what we have given current source. Okay, actually this is what guys, so this is the current dependent, which voltage dependent voltage source actually. Okay now, yeah, so this is the voltage dependent voltage source and this is the current, and this voltage is depending on this voltage, guys. Okay now, is it clear now? Now we have to calculate this I2 by I1 ratio, guys. We have to calculate the ratio of I2 by I1, the ratio of this I2 by I1. Okay now, so it's very simple. Okay, again, so first of all I'm just finding this value of I2. Okay now, is it clear? Is it clear? So just tell me please, what is the value of this node voltage, guys? If I'm talking about this node, what is the voltage of this node? Can you please tell me? Can you please tell me the value of the voltage at this node, guys? Just respond please. Okay, so it's very simple. What we can say, sir, as this is the reference point, and as you know, the node voltage is always defined with respect to ground. So just try to move, or just try to go from this point to that point, guys. Just move from this point to that point only. Why it is 0.5 volt? Krishna, why it is 0.5? Where is 0.5? So it's simply this voltage only na. Simply this voltage only na. Okay na? So what we can write, this is nothing but alpha V. And if it is not visible, so it is alpha, not 0.5. Is it clear na, Krishna? Okay. So this is alpha V. So I'm writing here alpha V. Okay. And if it is alpha V, so can you please tell me the current which is I2 here? Which is I2 here? Okay. So yeah, it's very simple again. So what we can write? So we can write, sir, I2 is the current through this resistor, and through this resistor, the voltage across this resistor is alpha V. That's why alpha V by R is the I2. Is it clear? So again, I'm using, okay, so simply I'm writing here, I2 is equal to what? Alpha V by R. Is it clear? Is it clear now? So from here, what we can say, guys, V is what? What is V here? So we can say V is equal to R into I2 divided by alpha, and assuming this is equation 1. I am assuming this is the first equation only. Okay. Now what we have to do, guys? So here we have applied what, guys? Simply Ohm's law only. Is it clear? Correct now? Now again we have to, as we have to calculate what ratio of I2 and I1. So we have to relate these two terms. Okay now? So what we can do here, we can say as the voltage of this terminal is this voltage V only. So let us suppose this is V. Okay now? And this current is what? So this current is I1. Okay. And if this is I1, this current is V, this voltage is V, this voltage is alpha V. So we can assume this current and this current also. We can find this current and this current also. Okay now? So I'm not writing any current here. I'm just saying what is this? So this is the direction of current. This is the direction of current. And here we are applying node analysis, guys. Here we'll apply node analysis only. Okay now? So let us apply node analysis here. So write KCL at node V. Okay. So what is the value of KCL, guys? So the incoming current is I1. So I1 is equal to V by R. So here I'm writing the incoming current is this is I1 is equal to V minus of 0 and this divided by R. Okay. What about the next current? Okay. So this is what? V minus alpha V divided by R. Okay. So this is V minus of alpha V and this divided by R. Is it correct? Is this correct now? So just simplify this, guys. So this is the value of R only. And what is this? So this is V, and this is what? This is again V, and this is minus of alpha V, guys. Okay. So we can write here, this is 2V minus of alpha V and this divided by R, guys. Okay. And this is nothing but I1. And this is nothing but I1. Is it clear to all? Yes or no? Respond please. Okay. So what we can write here, we can just taking common of voltage V, guys. Okay, now I'm just taking common V. So what is this? So this is V into what is this, guys? So this is 2 minus of alpha, and this divided by what? R. Is it clear? And this is our equation 2. This is our equation 2. Okay, now. So from equation 1 and 2, can we write in place of V, this is RI2 by alpha. Okay, now. And by that equation, we can find the value of I2 by I1. Is it clear now? So again, here I am writing what, guys? So simply I am writing what? From equation 1 and 2, guys. From equation 1 and 2. What we can write here? What we can write here, guys? So from this equation, we can write, I1 is equal to, what is this? V is equal to R I2, and this divided by what, guys? Alpha into, this is 2 minus alpha, and this divided by R, guys. And this divided by R. Is it clear now? So this R will cancel this R, guys. Okay. So here what we can write? We can write the value of I2 by I1 is equal to what, guys? I2 by I1 is equal to what? So this is alpha divided by 2 minus alpha. Is it clear? And this is the correct equation only. This is the correct answer only. Okay. So just see the option, guys. Which option is correct? Which option is correct? Just tell me, please. Which option is correct? So alpha by 2 minus alpha. So this is option B, guys. Is this correct? Yes or no? Is this correct? Because alpha by 3 minus alpha, it is wrong. Alpha by 2 minus alpha. Is this now? Alpha by 2 minus alpha. Yeah, very good. So alpha by 2 minus alpha. So this is correct. This is again wrong. Alpha by, again this is wrong. So option B is correct. B, Bombay is the correct answer, guys. Alpha पे nodal. Okay. So here, yeah, again, what? Just see. अब देखो हम लोग रुपीस क्यों कर रहे हैं ऐसा, देखते हैं. जस्ट सी कि यदि हम लोग यहाँ पे नोडल लगाना चाहें, अगेन वी कैन अप्लाई, डेफिनेटली वी कैन अप्लाई, बट फॉर अप्लाइंग नोडल वी शुड नो द करंट, or we can say the current through all the branch, guys. If you are applying here node analysis, then again you have to assume one variable, guys. Just we have to create one variable here. Why we are creating one more variable? As we can find this problem very easily. Okay, so why we are creating one more variable? Is it correct ना? यहाँ पे उसका कोई मतलब है नहीं ना, कोई मतलब है क्या, है ना. सो हमें जब पता है I2 का वैल्यू मिल रहा है इजिली, सो अब हमें क्या चाहिए, I1 का चाहिए ना इन टर्म्स ऑफ I2. दैट्स व्हाई वी आर अप्लाइंग नोडल एनालिसिस हियर ओनली. इज इट क्लियर टू ऑल? यस और नो? इज इट क्लियर? यस और नो? Is it clear to all? Yes or no? Respond, please. Is it clear, Rupesh? Is it clear? Yes or no? Chalo. Very good, guys. है ना? So the correct answer is what? Correct answer is B. B for Bombay is the correct answer. Okay? So ये बहुत easiest way है जिससे कि हम लोग फाइंड कर सकते हैं और ऐसे क्वेश्चंस को सॉल्व कर सकते हैं, है ना. मैंने पहले भी बोला था आपको कि हम लोग बहुत छोटे छोटे क्वेश्चंस पे ही, है ना, ध्यान रखेंगे. We'll start from very basics only, okay ना, and then we'll increase level one by one, okay ना. Suddenly आपको अचानक से बहुत tough question मिल जाएगा ना, then you will not able to find and not you will not get anything, okay ना. Is it clear ना? Yeah, very good, Rupesh. Okay, so here we are here to learn something, guys, okay ना. Is it clear? Very good. चलो, just try to find this, guys. Just try to solve this. Do it fast, please. Do it fast, please. So again, this is a good question, guys. Okay, and try to solve this question. For solving this question, I am giving you 2 minutes, guys. Okay, do it fast, please. Do it fast. Do it fast, please. Do it fast, please. Do it fast, guys. 38 seconds is remaining. Do it fast. Do it fast, please. Option A. Okay. Very good. So let us check. Okay. What are you doing, guys? Remaining all, give your, yeah. So time's up, guys. Okay. What about all, guys? Yeah. So just tell me, please. First of all, tell me how to solve this type of question, guys. Okay. How to solve this type of question? Actually, how to approach this type of questions? Okay. What we can do here? Just see. Shall I do like this? Yes or no? Just tell me, please. Just tell me, please. Can I do like this? Okay, sorry. Yeah, sorry. Yeah. Balance breeze. Okay. Yeah. Star to delta. Okay. Very good. So we have multiple options. Yes, is it now? Okay. So which is the easiest way? Okay, now. Which is the easiest way? We'll do here. Okay, now. So just tell me, please. Shall I do like this? Is it correct? Just tell me, please. So this 2 is in series, and this series part will be in parallel with this 10 ohm, and this will be in series with this 10 ohm. This will be in series with that 20 ohm. This will be in parallel in this 10 ohm. This will be in the series with this 10 ohm and 5 ohm. Is it correct? Is it correct way? क्या हम लोग ऐसा कर सकते हैं? Just respond, please. Respond, please. Respond, please. Is it the correct way to solve this question? Is it correct approach? No. No, it's not correct, Nitin. Not correct. Okay, so Krishna is saying A. Okay, let us see, Krishna. Okay, why it is not correct? Just listen, please. Okay, now actually what we have to find the resistance, or we can say the equivalent resistance across this terminal, guys. And when you are just seeing from this point, what you will get? So this is not in parallel connection, guys. Is this 2 connected in, sorry, this 2 is connected in series by seeing here only. Okay, now when it will be in series, when the current is flowing same in these 2 resistance, guys. When the current will be same for these 2 resistance, guys. But when you supply any current, when you will supply any voltage here, when you connect any voltage here, then the current will split here, current will divide here. Is it clear now? Is it clear? Yes or no? नहीं कर सकते ना रुपेश, we can't do. वही तो मैं बता रहा हूं ना कि सीरीज पैरेलल यहां से, हाँ यहां से कर सकते हो आप, यहां से कर सकते हो, लेकिन यहां से आपको पता हो रहा है क्या? यहां से आप बता सकते हैं क्या? इज इट पॉसिबल टू कमेंट अबाउट दिस टू कि ये सीरीज में है, पैरेलल में है? नो, वी कांट. ओके ना? और यदि ऐसा हम नहीं कर सकते देन व्हाट वी कैन से, है ना, हम लोग क्या कह सकते हैं जी? सो जस्ट वी हैव टू अप्लाई सिंपली, जस्ट वी सी कि क्या हम लोगों के पास क्या क्या ऑप्शन, पॉसिबल ऑप्शंस है. तो ये हम लोग देख पा रहे हैं कि क्या ये हमारा डेल्टा की तरह दिख रहा है क्या? इज इट लाइक डेल्टा? ओके ना, यहां पे भी डेल्टा की तरह दिख रहा है, तो हम लोग कहां लगा सकते हैं? वेयर वी कैन अप्लाई स्टार डेल्टा कन्वर्जन. इज इट क्लियर ना? सो देखो तो मैं यहां पे क्या कर सकता हूं, है ना, मैं यहां पे लिख रहा हूं, इधर मैं लिखता हूं. चलो, ही आई एम राइटिंग सपोज पहले मैं स्टार डेल्टा की बातें कर लेता हूं। Okay, so let us suppose this resistance is RA, this is RB, and this is RC. Okay, so what is this, guys? So this is the delta connection. This is the delta connection of a network, of a resistor only. Okay, so next if I am drawing here, one resistance is here, one resistance is here, and the another resistance is here only. Okay, and let us suppose this value is R1, this value is R2, and this value is R3. Okay, so what is this, guys? What is this? So this is the star connection. You can say star connection or Y connection or T connection. Is it clear now? What about this, guys? So what about this? This is what? So this is what? So this is delta connection, or you can say this is pi connection. Is it clear now? Okay, so अब देखो यहां से क्या हमारा ऐसे ही बन रहा है क्या? Is it like that? Is it okay now? Yeah, exactly. We can do by equipotential also. Okay ना? देखो हम लोग वन बाय वन देखते पहले। तो यदि हम लोग बात करें, सॉरी, है ना, तो कंफ्यूज नहीं करना, हम लोग वन बाय वन मेथड को सीखते चलते हैं पहले। सो व्हाट वी कैन डू हियर, सो जस्ट राइट स्टार टू डेल्टा और डेल्टा टू स्टार. So here I am writing star to delta equation. So star to delta means what, guys? We are just converting this star to delta. Okay na? So we have to write equation for this. We have to write the equation for delta. Is it now? So delta we have what, guys? So we have the value of RA. So for delta we have the value for RA. So how to calculate this RA, guys? RA, so this RA will be nothing but R1. So this is R1 into R2. I am giving shortcut also. So this is what? R2, trick also. R2 into R3 plus of R3 into of R1, and this divided by what, guys? And this divided by, just see RA, and just in front of this resistance, just see in front of this resistance, which is what, guys? R2. Okay now, what about RB? What about RB? So the numerator part will be same. This is what? R1 R2 plus of R2 R3 plus of R3 R1, and what will change, guys? Denominator part will change. So again we are calculating what? RB. So in front of RB, which is R3, so we will write R3 only. So what about RC? So again numerator part will be same, which is R1 R2 plus of R2 R3 plus of R3 R1, and this divided by denominator part will be, so actually we are calculating RC. So in front of RC we have what? R1. In front of R1, sorry, RC we have R1. So this is the value of what, guys? So this is the value of delta. But delta is given to you, guys. Delta is only given to you. Okay, now when you connect this terminal to here, so it will be like a delta. Or you can see it is a pi type sign, pi type of things. Is it clear now? So what we have to calculate here? So we have to calculate here what, guys? Okay. So we have to calculate here. Okay. So just we have to calculate this one. Just we have to calculate this one. Means what? We have to calculate T, or you can say Y, or you can say star. Is it correct? Is it clear? Yes or no? So how to calculate this value, guys? Okay na? So again let us see here. Sorry. Again let us see. So what we have to calculate now? So we have to calculate the value of R1, R2 and R3. How to calculate this? Just see here. R1 is what? So R1 will be RA into RB. So this is RA into RB, and this divided by RA plus RB plus RC, which is RA plus of RB plus of RC, guys. ये clear हो पा रहा है? So what about R2, guys? So R2 is what? R2 is nothing but this RB and RC. Just see the adjacent RB and RC, and this divided by RA plus of RB plus of RC, guys. And what about R3, guys? What is R3? So R3 is RA into RC, and again denominator part will be same, which is RA plus RB plus RC. Is it clear to all? Yes or no? Is it clear to all? Yes or no? Respond please. Okay ना? So देखो सिंपली मैं याद रखने का तरीका बता रहा हूँ जी. जस्ट या एग्जैक्टली मैं वही बता रहा हूँ रुपेश. जस्ट ध्यान से सुनो. ओके ना? देखो हम लोग क्या कर रहे हैं, ध्यान से सुनना. ये स्टार है ना, ये स्टार है ना, तो स्टार हम लोग कब लिख रहे हैं? सो हम लोग स्टार लिख रहे हैं, वी आर राइटिंग स्टार, है ना. सो व्हाट इज दिस? सो दिस इज डेल्टा टू स्टार, डेल्टा टू स्टार कन्वर्जन. So this is delta to star conversion. So we are writing star only. Here we are writing delta. Is it clear ना? तो आप देखो, याद रखो कि डेल्टा में देखो क्या चेंज हो रहा है. तो डेल्टा में नीचे का पार्ट चेंज हो रहा है, स्टार में ऊपर का चेंज हो रहा है. तो आप इस तरह से याद रखो कि ऊपर का चीज कैसे लिख रहे हैं हम लोग. सो R1 इज व्हाट? R1 इज RA इंटू RB, R2 इज व्हाट? RB एंड RC, R3 इज व्हाट? RA एंड RC, है ना. बाकी क्या है? R1 प्लस RB प्लस RC, सारे में वही है ना. तो हमेशा इस तरह से याद रखो कि जब भी हम लोग स्टार की बात करते हैं ना, स्टार ऊपर में होता है ना हमारा, तो स्टार में सिर्फ ऊपर के पार्ट चेंज होंगे. द न्यूमरेटर पार्ट विल चेंज इन स्टार कनेक्शन ओनली. एंड सिमिलरली वी कैन से एज डेल्टा इज, है ना, हमारा डेल्टा का होता है जी नीचे होता है, जमीन पे धरती पे होता है ना, तो डेल्टा हमारा नीचे का पार्ट चेंज होगा, है ना. क्या चेंज हो रहा है? डिनोमिनेटर पार्ट ओनली. न्यूमरेटर सारा सेम है ना, न्यूमरेटर सारे सेम है ना, है ना. सो जस्ट आप इस तरह से भी याद रख सकते हो इसे. इट्स वेरी सिंपल कि आप इस तरह से रिमेंबर करो कि जब स्टार की बात करते हैं ऊपर का चेंज होगा, डेल्टा की बात करते हैं तो नीचे का चेंज होगा. इज इट क्लियर? कैसे लिखना है ये तो हमें लिखने आ गया. इज इट क्लियर टू ऑल? यस और नो? हाउ टू राइट दिस, ये तो बहुत क्लियर है. कैसे मैंने बोला आर ए लिखना है. सो आर ए के लिए मैंने क्या बोला कि आपको इसके सामने देखना है, वो चेंज होगा, मतलब R2 चेंज होगा. उसके ऊपर का क्या होगा? इट विल बी R1 इंटू R2 प्लस R2 इंटू R3 प्लस ऑफ R3 इंटू R1. इज इट क्लियर ना? एंड दिस डिवाइडेड बाय R2. इसके बाद क्या होगा? सो जस्ट सी, इफ यू वांट टू राइट RB, सो इट विल बी डिवाइडेड बाय R3. इफ आई वांट टू राइट RC, देन इट विल बी डिवाइडेड बाय R1. Is it clear? Yes or no? Is it clear? Yes or no? Respond please. Is it clear to all? Yes or no? Rupesh, just tell me please. Is it clear? Okay? Yeah, very good. So here what we can do, guys, here what we can do, so again we have to calculate what, guys? We have to calculate this R, है ना, star value. So what is this? So this is this into this into this divided by this plus this plus this. So what is this? तो यदि मैं सम की बात करूं, what is this? So this is 20 5 plus 10, which is 15 plus 10, 25. So this is 50 divided by 25. Is it correct now? Is it correct now? So this is 5 into 10, 50, and this is divided by 25. So this is 2 ohm, guys. So this is 2 ohm. Is it correct now? So this will be 2 ohm. Sorry. So this is 2 ohm. Okay, what about this? So this is 10 into 10, 100, 100 divided by 25, so this is 4 ohm. What about this? This into this, so this is 50, 50 divided by 25, so this is 2 ohm. Is it clear? Yes or no? Again, I am writing here, what is the summation, guys? So 30 plus 10, so this is 40 plus 15, so this is 55. Is it clear now? So total is 55. So what we can write? So this is 30 into 10, so this is 300, 300 divided by 55, so this is 300 divided by 55. Okay, what about this? So this is 150 divided by 150 divided by what? 55. And what is this? So this is 15 into 30, so this is how much? This is how much? 450 divided by 55. Is it clear? Yes or no? Is it clear? Yes or no? Respond please. Is it clear to all? Yes or no? Respond please. Respond please, guys. Is it clear to all? Respond please. Respond please, guys. Okay, yeah. So now again I am drawing this circuit, guys. Okay, here I am drawing the equivalent circuit of this here. Okay, so let us see guys, as we have a 2 ohm resistor. So this is the 2 ohm resistor. What we have guys? So here we have a 2 ohm resistor. So this is 2 ohm resistor, and this resistance is of 10 ohm. So this is 10 ohm, and this one is 4 ohm. So this is 4 ohm, and this resistance is of 20 ohm. So this is 20 ohm. Okay, so just tell me the value of this guys. 150 by 55 is how much? Rupesh, just tell me 150 by 55 is how much? Just tell me the value of these. Just tell me the value of all these. Okay, so first is 150 by 55. 150 by 55. Just tell me the value guys. Just tell me the value. Respond please. Respond please. है ना? So फटाफट वैल्यूज बताएं. Okay, and the last resistance is this. So this terminal is A and this terminal is B guys. Okay, so just tell me the value. So 2.727. What is this? So this one, is it correct now? So this is 2.727. Is it correct? Very good. And what about this 300 by 55? So I think it will be just 2 times now. So this is 4.54 something. Is it correct now? No. So this is, sorry. So this will be what guys? So this is 5.45 something. Is it correct now? 5.454. Yeah, very good. 5.541. And what about this guys? So this is 3 of this. So this will be 8 point something. 8.1 something now. 8.18. Very good. 8.18. Very good. Very good. So now is it easy? Now is it easy? Is it easy now? Just now tell me the R equivalent value guys. So here I am writing the value of R equivalent. Okay now, here I am writing the R equivalent value. R equivalent. Okay, so the value will be what guys? So this is what? So this is 2 plus 10. So this is 12. 12 plus 2. So this is 14.727 ohm. What about this? What about this? So this is what guys? So this is 4 plus 2 and 20. So 24. And this is 5 point this. So this is 29.45 ohm. Is it clear now? Is it clear? So again I am redrawing. Okay, yeah. So again I am drawing this. So this is 2 plus 14.75. So this is 2. So this is what guys? So this is 2 ohm and this is another resistance which is connected with a resistance which is having the value of 8 point something. Okay, so this is terminal A, this is terminal V, this is 2 ohm. What is the value of this one guys? So the value of this one is 14.727. So this is the 14.727. So this is 14.727 ohm. Okay, what about this one? So this is 29.45. So this is 29.45. And what about this one guys? So this is the 8.18. 8.18 ohm. Okay, so now find the value of RAB guys. Just write the value of RAB. Do it fast please. Do it fast please. Is it 8.18 or 9.81 rupees? Is it 8.18 or 9.81? Okay, so are you Which one is 9.81? So are you telling about this one? Rupesh, are you telling about these two parallel? Yes or no? Why are you just confusing? Just right here. What I'm writing here. So this is what? 2 plus of what? So this 2 in parallel. So this is what? 14.727, and this is parallel with 29.45. Okay, and this is in series with the 8.18 ohm. Is it clear now? Is it clear? Yes or no? Okay, very good. So this is 20.56. So let us see. So this is 8. So this is 10.18. And what is the value of this, guys? What is the value of this? R equivalent is 20. Very good, Rupesh. Very good. Ankit, no, not, it's not 50. Just check your calculation. Okay. So just tell me the value of this, guys. I think this will be, yeah, so 9.81. Very good. 9.81. So this is 9.81. Yeah, na? So it is approximately equal to 20 ohm, guys. Okay. So this is the correct answer, guys. So this is the correct answer, guys. So the correct value is RAB. Sorry. So the correct answer is RAB is equal to how much? 20. Is it clear? Is it clear to all? Yes or no? Is it clear to all? Yes or no? Is it clear to all? Yes or no? Respond please. है ना? Okay. Very good. Very good, guys. So the correct option is how much, guys? Correct option is what? Sorry. So the correct option is A, 20 ohm. Okay. Correct option is 20 ohm. Very good. Very good, Krishna. Okay. So let us try this question, guys. Okay. So let us try this question. No, it's not time consuming method, Rupesh. It's not time consuming method. If you are very, है ना, if you are very in practice na, it will take around 2 minutes, है ना, 1.5 and 2 minutes only. Okay, and it is the easiest method. Okay ना, and one more thing, हमने यहाँ क्या सिखाना था? स्टार डेल्टा की भी बात करनी थी, क्योंकि स्टार डेल्टा से बहुत सारे क्वेश्चंस पूछे गए आपसे. ओके ना? इज इट क्लियर? ठीक है, मैं उससे भी बता देता हूं. ठीक है, पहले ये कर लेते हैं, फिर मैं बताता हूं, है ना. लेकिन वो मैं हमेशा यही कहूंगा कि ऐसे केसेस में आप उससे भी बताए, स्टार डेल्टा से किया करो. इट विल बी वेरी इजी. ओके ना? और भी क्वेश्चंस हैं, मैं जो दिखाऊंगा आपको कि स्टार डेल्टा से ही बनाओगे आप तो ज्यादा इजी बनेगा. बहुत सारे क्वेश्चंस ऐसे होंगे. ओके, क्यू पोटेंशियल से भी बना सकते हैं, बिल्कुल बना सकते हैं. ओके, just try to find this file first. Okay na? Then we'll tell you. Okay, do it fast please. Sorry. Do it fast. Do it fast please. Okay, so just try this question, guys. Here I'm just taking break of just 5 minutes. Okay na? So in this break just try to find the answer, guys. Okay na? Okay, so we'll meet after 5 minutes. Okay na? Yeah. Okay, so is it audible? Krishna, is it audible? Is it audible, yes or no? Is it audible, yes or no? Okay, yeah. So what I told, after this will cover, after this, okay, yeah. So Krishna is saying C. Okay, so let us see. After this topic will cover, Rupesh, network theorems. Okay, now. So in network theorems, okay, yeah, okay, sir, thank you. Okay, now. So after this will cover network theorems, guys. Okay, now. Network theorems, Rupesh. So in network theorems, okay, so in network theorems we'll deal all the theorems, guys. We'll start from superposition, then we'll deal Thevenin's, then we'll deal Norton's, then we'll deal maximum power transfer theorem, and we'll deal all the cases of Thevenin's, Norton's and maximum power, as well as what, reciprocity theorem, guys. Okay ना, so we'll do all the things. Okay ना, ठीक है रुपेश, मैं वो भी बता देता हूँ, एक एक करके सारा कुछ मैं बता दे रहा हूँ, आप है ना, उसे भी बता देता हूँ मैं. ओके, चलिए. Let us see, guys. Now what we can see here, यदि हम लोग बात करें तो हमें क्या पूछा गया जी, फॉर द सर्किट shown in the figure the current I1 is given by, the current I1 is given by, what is current I1? So this is current I1, guys. So this is current I1. Is it clear ना? अब देखो कि if you want to apply what, guys, node analysis, if you want to apply node analysis here, so to apply node analysis we should have this nodal value and this nodal voltage also. Is it clear, yes or no? Is this correct, yes or no? Respond please. Is this correct, yes or no? Respond please. Okay now. So but what we can see here, what we are seeing here, guys, so in this two node we have a voltage source, guys. Is it clear now? Okay, so let us see, Rupesh. So in this two node we have a voltage source, guys. Okay now, and if in any network in between two node there is a voltage source, or if in between two mesh there is a current source, then we have to apply and of concept of what, guys, super mesh or super node, guys. Is it clear now? So here, as we have a voltage source in between these two node, then we have to apply what, guys, super node. Very good, Rupesh. Is it clear now? So how to find or how to apply super node, guys? And actually what a super node means, guys. Is it clear now? So super means what? Super node means what? If in between two nodes there is a voltage. Okay, so what are the steps we have to follow here? So there is very simple steps, guys. What we have to do? So the node, or we can say the branch which are creating, the branch which is creating super node, just remove that branch first. Okay, and make that two node as a single node and write the KVL. Sorry, write the KCL only. Sorry, it's KCL only. Okay, now node analysis, we are in node analysis we are dealing with KCL and Ohm's laws. Is it clear now? So here what I'm doing, okay, so what I'm doing, so I'm writing write KCL at super node, write KCL at super node. Okay, so what are the equation for KCL, guys? What are the equation for KCL here? So as we can see, this is the outgoing current. Again I'm assuming this is the outgoing current, this is the outgoing current, this is the outgoing current. Okay now, so here we can write what? We can write 4, which is the outgoing current, plus of what is this, guys? So this is V1 minus of, again I'm assuming this is the reference node, guys. This is the reference node. So what we can say, this is V1 minus of 0 divided by what, guys? 50. Is it clear? Okay, very good. And as you remove this node, I'm resuming this branch actually, removing this branch actually. Okay now, so we have this node only. So what about this node, guys? So here we'll write V2 minus of 0 and this divided by what? 150. 150 plus of what? Plus of V2 minus of 0 and this divided by what, guys? 75. 75 and this must be equal to 0 and this must be equal to 0. Is it clear, yes or no? Is it clear to all? Yes or no? Respond please. Okay, so what we can write here? So we can say here, guys, 4 plus of, just taking LCM, which is 150, and what is this, guys? So this is 3 times V1 plus of V2 plus of 2 times V2 and this is equal to 0 and this is equal to 0. So what is this, guys? So here I am writing, so this is 3V1 plus of, what is this? 3V2 and this is equal to minus of 600. So what we can write? So we can write V1 plus of V2 and this is equal to minus of 200 only, and this is the equation 1. Is it correct, yes or no? Is this correct, yes or no? Respond please. Okay, so this is the first equation, guys. Now as we have two variable, to find these two variable we should have two equation, guys. So from where we get second equation? So here as you can see, so this is voltage V1 and this is voltage V2. So just by applying KVL we can write easily what, guys? Voltage equation. Okay na? So here I am writing, what is this? So this is V1 minus of V2. This difference is nothing but 50 volts. Is it correct, yes or no? Is it correct, yes or no? So from this and this we can find the value of V1 and V2, guys. Okay, so let us write from equation 1 and 2, from equation 1 and 2 what we have actually? So we have V1 plus V2 is equal to minus 200. So this is V1 plus V2 is equal to minus 200 plus of is equal to V1 minus V2 is equal to 50. So this is V1 minus of V2 is equal to 50. So just tell me what the value we have, guys. So by adding this will be cancel out, so we can write 2V1 and it is equal to minus of 150, guys. So therefore we can write V1 is equal to minus of 75 volts. Minus of 75 volts. And what we have to calculate, and what about B2, guys? And what about B2? And if you want to find B2, so just write as V1 is equal to minus of 75 minus of V2 and this is equal to 50. Okay, so how to write this? So therefore V2 is equal to minus of 75 minus of 50. So this is how much? So this is minus of 125 volts, guys. Okay, is it clear? Now what actually we have to find? We have to find this value I1. So what we can write? I1 is equal to V1 by 50. So we can write here, as I1 is equal to what, guys? V1 by 50. What is the value of V1? So as we have V1 is equal to 75 minus of 75 and this divided by 50. Okay, so just tell the value, guys. Just tell the value. Is it minus of 1.5? Is this correct, yes or no? Is it correct, yes or no? है ना? So this is what, guys? 3 and this is 2. So we can write minus of 1.5 volts. So which is the correct answer, guys? Okay, so option D is the correct answer. Option D is correct. So how many of you got the correct answer? Krishna, minus, yeah, so minus 1.5, very good, Rupesh, very good. Okay, chalo, very good, guys. Okay, very good. So let us do now this question. Do this question, guys. and please try to solve fast, please. Okay, we have many questions. Actually, we have many questions and we have to solve in this session only, guys. Okay, so just try to find and just increase your speed, please. Increase your speed, please. Okay, again, this is a very good question, guys. This is very good question. Okay, this is very good question, guys. Just try to find this. Do it fast, please. Do it fast, please. Do it fast, please. Do it fast. Do it fast, please. Do it fast, please. Okay, so let us see, guys, how to solve this type of question. So in many students, actually I have seen in many students there is a confusion. Which type of confusion? So बहुत आप में से ये सोचते हो ना कि सुपर पोजिशन पढ़ने की जरूरत नहीं है, नो नीड टू स्टडी सुपर पोजिशन थ्योरम, बिकॉज कि यदि गेट में बोला जाएगा तो भाई दूसरा मेथड है हमारे पास, वी कैन अप्लाई दैट मेथड ऑल्सो. इज इट क्लियर ना? सो here you don't have another option, guys. You don't have, just you have to apply superposition. Intentionally he is giving you he is resisting you to apply superposition theorem. Okay na? So by the concept of, by the help of superposition theorem only, or we can say the principle of additivity only, you can find the value of this current I of 3. Is it clear now? Okay, so how to attempt this type of question? Let us see here, guys. So actually what we have in the circuit, superposition is applied. Okay na? He is given superposition is applied. It is given to us when V2 is set to 0. So here what we have, actually I am writing here, we have given when V2 is set to 0. So when V2 is equal to 0, when V2 is equal to 0, the I2 is equal to minus of 5 ampere. So I of 2 is equal to minus 5 ampere, guys. And when second point is given to us, when V1 is set to equal to 0, then the value of current I1 is equal to plus of 5 ampere, guys. Plus of 5 ampere. Is it clear, yes or no? Is it clear, yes or no? Now what we have to calculate, he is saying current I3 in ampere when both the sources are applied will be. Okay, now what we have to do, what we have to calculate, so we have to calculate this value I of 3 when this voltage V1 and V2 both are applied simultaneously, guys. Is it clear, yes or no? Is it clear to all? Yes or no? Respond please. Okay, so simply what we have to do, guys, we have to apply superposition only, we have to apply additivity principle only. Is it clear to all? Okay, so let us see one by one, guys. Okay na? So here I'm just considering case 1, guys. I'm considering case 1. What is case 1? So in this case 1, I am taking what, guys? What is given to you? So we have given when V2 is equal to 0 and I2 is equal to minus of 5 ampere. So here I am writing when V2 is equal to 0 and I of 2 is equal to how much, guys? So this is minus of 5 ampere now. Yeah, so this is minus of 5 ampere. So this is minus of 5 ampere. Is it clear? Is it 0? 0? No, it's not correct, Krishna. It's not correct. Okay, so let us see first. Okay na? So what है ना? So let us draw in this condition, guys. Actually we have 3 resistance now, and in this case we are just doing what? I'm just doing short circuit this V2, guys. Okay, so let us see. Okay, yeah, sorry. Yeah, so we have the circuit like this, guys. Okay, so this is V1. What is the resistance? The value of resistance is how much, guys? 363. Sorry, 362. Okay, so this is 3 ohm, 6 ohm, 2 ohm. And what is this? So this is the current I2, guys. This is the current I2. Is it correct now? Is it correct now? So let us assume this voltage is nothing but Vx. I am assuming this voltage is nothing but Vx. When it is Vx, when only V1 is acting alone. When V1 is acting alone, guys. When V1 is acting alone. Okay, so let us find the value of Vx, guys. So is it possible to find the value of V of x? Okay, so let us try. So what we can write? So we can write this Vx, V of x is nothing but what, guys? So this is 2 into I2. 2 into I2. And this I of 2 is given to you, as this I2 is given to you. So what we can write? So simply we can write this 2 into I of 2 is what? So this is minus of 5. That's why we can write minus of 10 volts, guys. And this is our equation 1. And this is our equation 1. Okay, is it clear to all? Yes or no? Is it clear to all? Yes or no? Respond, please. Now what I'm doing, I'm just considering case 2, guys. I'm considering case 2. So in case 2, when we have given, when V1 is equal to 0 and I1 is equal to plus of 5 ampere, guys. Plus of 5 ampere. So again we are drawing the circuit. Again we are drawing circuit, which is what, guys? So this is voltage V2. Okay, again we have a resistance here, and this is short circuited, guys. So this is what? So this is voltage V2, and this resistance is 2 ohm, this one is 6 ohm, and this is 3 ohm. Okay, so the current I1 is what, guys? So this is the current I1. Again this is the current I1. So what we can say here, I am assuming this voltage is nothing but Vy. I am assuming this voltage is Vy. When this voltage will be Vy? When I am assuming V1 is equal to 0. V1 is set to 0. Okay, or we can say when V2 is acting alone. When V2 is acting alone, then this voltage, this node voltage will be Vy. Okay, so what we can say here, sir? So again, is it possible to find the value of Vy? Yeah, it's possible. It's very easy. So how to write? So the Vi is nothing but 3 times I1, and this is the value of I1 is 5. So this is 3 into 5. That's why I'm writing 15 volts is the value of Vy, guys. And this is our equation 2. This is our equation 2. Now what we have to calculate? So we have to calculate, guys, the value of I3 when this voltage V1 and V2 is acting simultaneously, guys. It means that when you are adding, or when you are just supplying V1 and V2 simultaneously, it means that the node voltage will be what, guys? Summation of these two. then node voltage will be summation of these two. Is it correct, yes or no? Is it correct, yes or no? Okay, so let us see. I am applying here now. I am applying here, apply superposition method. So here I am writing by superposition method. By superposition method. Superposition method. So what we can guys, what we can do guys? So by superposition method means what? है ना कि when both V1 and V2 are acting. Okay, so the circuit will be like this. The circuit will be like this. So this is plus minus V1. Okay, so this is what? A resistance, and this is the voltage which is V2, plus minus V2. Okay, and the value of the resistance is 362. So here I am writing 3 ohm, 6 ohm and 2 ohm. Okay now? Now if I am asking to you, just tell me the value of this voltage. If it is V, then what is the value of V? So what is the value of V? Just tell me please. And if it is V, what is the value of V guys? Just tell me please. Okay, so simply we can say, sir, V is nothing but, by superposition law, we can say V is nothing but Vx plus Vy. Why sir? Because Vx is the node voltage at when Vx is the node voltage when V2 is acting alone, sorry, V1 is acting alone, and Vy is the node voltage when V2 is acting alone, and when with these two are acting simultaneously, then this V will be summation of these two, and this is what guys? So V1 is, sorry, Vx is how much guys? Minus 10 and 15. So here I am writing, so this is minus of 10 plus of 15, which is equal to 5 volts, which is equal to 5 volts. Okay, so now just tell me one thing. If it is 5 volt, so is it possible to find the value of I3 now? Is it very simple, yes or no? So yeah, very simple. So therefore we can write I, which is I3, is equal to how much guys? So this is 5 by 6, and this is the correct answer only. And this is the correct answer only. Is it clear to all, yes or no? Is it correct? Is it clear to all? Yeah, very good. Very good. Very good. So just we have to understand one thing from here guys. If you can see, there is such type of question in PYQs guys of GATE. Okay ना? It means that कि GATE को पता है कैसे क्वेश्चन पूछना है. Is it clear ना? है ना? Is it clear, yes or no? Is it clear to all, yes or no? Okay. So superposition is very, very important concept guys. Superposition theorem is very, very important theorem. Okay na? So by just this concept, there are many questions guys from additivity, homogeneity and power. Okay na? We'll do all the things from here in this session also. Is it clear now? We'll discuss all the session, all the concepts in this session. Okay na? Actually we have 2 sessions. So first is today and second is tomorrow also. Okay na? So the remaining part we'll discuss in tomorrow also. Okay na? But we'll try to cover maximum question, maximum part in this session also. Is it okay na? For this we have to increase our speed also guys, so that we can cover maximum number of concepts here guys. Is it clear? Okay. Exactly. मैं बता दूंगा पेस, डोंट वरी, आई विल टेल ऑल द थिंग्स, है ना. मैं बस थोड़ा सा स्पीड लेट हो रहे हैं, इसलिए हम लोग फटाफट करते चलें. मैं आपको इक्विवेलेंस से बता दूंगा, टेंशन ना लो आप, बहुत बेहतरीन तरीके से बता दूंगा. इज इट ओके ना? इज इट ओके ना? मैं और भी एग्जांपल्स लेकर बता दूंगा आपको, डोंट वरी फॉर दैट. इज इट क्लियर? ओके या इज इट क्लियर? चलो फटाफट ये सब क्वेश्चंस कर लो, फटाफट करते चलो. पहले वो मैं लास्ट बता देता हूं आपको, है ना, क्योंकि वी आर वेरी लेट गाइस, है ना. एक्चुअली We have to do many questions, but we are still in 13. Okay, वो मैं बता दूंगा रुपेश, पहले करिए फटाफट ये सारे क्वेश्चंस को करते चले पहले. Do it fast, please. Do it fast, please. Do it fast, please. Do it fast. थोड़ा फटाफट करो आप. Okay, so let us see, guys. Let us see here. What we have to calculate here. What we have to calculate here. Okay. The power dissipated in the 1 ohm resistor. Just try to understand this question. A very good question, guys. This is very good question. Okay, now. So what is given to us? The power dissipated in the 1 ohm resistor. So this is 1 ohm resistor. Okay, now. So this is 1 ohm resistor. Okay, is 1 watt. Is 1 watt due to the 5 volt voltage source alone. Means what? Ki this resistor R, suppose I am just writing this resistance is R. So this resistance is dissipating how much? 1 watt power when this 5 volt is acting alone, guys. Means that this current source is deactivated. It means that when this current source is open circuited, in this condition the power across this resistance R, which is 1 ohm, is 1 watt. Very good. Now, and 572 watt, so this is 576 watt, sorry, due to 30 ampere. So by this current, due to this current source alone, and when it is acting alone, means when this is deactivated, then the power through this resistance is 576 watt. Is it clear now? Now the total power absorbed in the same resistor due to both the sources is. What is the question? So again the question is what? When these two sources are acting simultaneously, then just tell me the value of what, guys? The value of power which is across this resistance, which is of 1 ohm. Is it clear? So simply what we can say, sir, again this is the question of what, guys? This is again the question of superposition principle, additivity principle. So again we'll will do what? As we know that superposition is saying what? Pt is equal to P1 plus P2. So we can say this power is how much? 1 watt, and this is how much? 576. So this is 576. So how much? So this is 577. Why is the correct answer, sir? So this will be the correct answer. Is it correct? Is it correct? Just tell me, please. Is it correct? Yes or no? Just tell me, please. Respond, please. Respond, please. Is it correct? इज इट करेक्ट, यस और नो? नो गाइस, ये बहुत बड़ा मिस्टेक करोगे रेस आप करोगे। ऐसा क्यों नहीं होगा सर? वाई इट इज नॉट करेक्ट? बट पिछले क्वेश्चन में आपने ये तो बताया भाई कि सही होगा, क्या गलत क्या है? व्हाट इज द रॉन्ग हियर गाइस? व्हाट वी आर डूइंग रॉन्ग हियर? जस्ट टेल मी प्लीज, just tell me please. Okay, what we are doing wrong in this question? Just tell me please, Ankit. Okay, why it is not correct by previous method? If we are applying previous method here, then why it is not correct here? Why we are getting wrong answer? Just tell me please. Okay, is it clear? Is it clear to all? Yes or no? Respond please. Rated power not be added simultaneously. Yeah, means why? Just tell me, what are the conditions for applying superposition theorem, guys? Just tell me please, what are the condition to apply superposition theorem here? Just tell me please, respond please. So just see here what we are saying. For applying superposition theorem, the first condition is what, guys? Just tell me the first condition only. What are the first condition to apply superposition theorem? So what we are saying, to apply superposition theorem, the circuit, or we can say the parameter should be linear, है ना? We are voltage and I can be added but power not. Very good Krishna. Okay na? So why we are just adding power, voltage and current only? Why not power? Because power is non-linear parameter, guys. We can find only linear parameters by using what? Superposition, or you can say additivity principle. Is it clear to all? Yes or no? Is it clear to all? Yes or no? So now again we are here, use that method only which we have used in the previous question to solve this question, guys. We are not using formula here. We'll create formula, we'll derive formula here. Okay na? So wow, how power is added in by the concept of superposition. Okay na? So just see here. So let us assume this resistance is R. Okay, I am assuming this resistance is R. Okay, just try to understand. I am just considering case 1, guys. I am just taking case 1. So in case 1, what I am assuming, when 5 volt is acting alone. When 5 volt is acting alone. Okay. So what will happen when 5 volt will act alone? So then I am assuming the voltage across this resistor is V1, or you can assume the current through this resistor is I1. Is it correct? Yes or no? Is it correct? Yes or no? Just tell me please. Is it correct? Yes or no? Respond please. Can I assume like that? If I am connecting this voltage 5 volt is alone, if I am removing this 50 ampere, then the voltage across this resistance R, or the current through this resistor R, is nothing but V1 and I1 only. Okay na? Very good Rupesh. Okay, so here I am assuming the current is I1. Okay, or you can assume the voltage is V1 also. Okay, and if it is correct, then what we can write here? So we can write, guys, then power P1 due to this, guys, 5 volt, what is this? So this is I1 square into R. Is it correct? Yes or no? This will be I1 square into R. Is it correct? Yes or no? Is it clear now? Now here I am just calculating, from here I am just calculating the value of I1, guys. So what is the value of I1? So this is nothing but plus minus root over P1 by R. So plus minus P1 by R. Is it clear? Yes or no? Is it clear? Yes or no? Clear hai na? Now again I am taking case 2, guys. So in case 2 what we are doing? So when current source is acting alone, guys. So the value of current source is how much? So this is 30 ampere. So this is 30 ampere. So when 30 ampere is acting alone, acting alone. Okay, so when 30 ampere is acting alone, then what will happen, guys? So then again I am assuming the current through this is I2. Due to what? Due to this only. Due to this only. We don't know the value of I1 and I2. We are just assuming the value. We are just assuming the current will be I1 in first case and I2 in the second case. Or you can assume the voltage is V1 in the first case and V2 in the second case. Is it clear to all? Yes or no? Is it clear? Yes or no? Now, what we can say, sorry, yeah. So now, what we can say, so again we are saying P2 is equal to I2 square into R, guys, into R. So again we are finding I2 is equal to how much, guys? So this will be root over P2 by R. Is it clear now? And this is our equation 2. This is our equation 2. Exactly. Very good, Krishna. Very good. Okay. Now what I am doing here? So we are doing what? So we are just applying superposition principle. So we can write here by superposition principle. By superposition principle. Superposition principle. Is it clear? So what we can write here, guys? So by superposition principle, we can say I total. So total current will be I1 plus of I2. Okay. So what is the value of I1, guys? So this is nothing but plus minus root over P1 by R and plus minus root over P2 by R. Is it clear? And here we can apply superposition principle, yes or no? Because this is the linear parameter only. Okay, na? And if you have linear parameter, then you can apply directly additivity principle, or you can say superposition principle, guys. Is it clear to all? Yes or no? Is it clear now? Now, if we apply superposition here, now we can comment about what? Power. So as we know, what, guys? Ki power, since power or V is equal to what, guys? I square by R. Sorry, I square into R. So we can write total power is equal to what? Total current square into R. Is it correct now? So here total current we have is how much, guys? So this is plus minus root over, what is this? So this is P1 by R plus minus root over P2 by R. Okay, and this is square into R, guys, and square of this into R. Is it clear? So when you are going to square this, so you can take common R. So what we can write? So we can write this is nothing but plus minus root over P1 plus minus root over P2 and square of this, and this is nothing but power total. Total power across this resistor, guys. Is it clear? It is not depending on what? The value of resistance, guys. Okay. So here as we have the value of P1 is how much, guys? So this is 1. So this is root over 1 plus minus root over how much this is? 576 and the square of this. Just tell me the value, guys. Just tell me the value of this. Just tell me, please. Just tell me the value of this. Respond, please. Respond, please. Do it fast, please. Do it fast, please. Okay. $625. Very good. So the answer will be plus minus 1 plus minus 24 and square of this. So the value will be what, guys? So this is 625 watt. 625 watt. Is it clear? Yes or no? Yeah, maximum value will be 625. Otherwise, yeah, exactly. Very good. This is the important point, guys. Krishna is saying the maximum value of the power will be 625. Otherwise, they can ask you about the maximum and minimum value, guys. And such type of question is asked in GATE PYQ guys. Okay na? So if you can see in previous questions, there are that type of questions. You have to find maximum power and minimum power both. Is it correct na? So how to find maximum power and minimum power? So just you have to, है ना, when it will be maximum, when you will get, you will take same sign, either positive or negative, because square of positive or negative will the same. Is it correct now? When it will be minimum, just you have to subtract. When in this case, suppose this is 24 and this is minus of 1, so this is 23, and 23 of a square is what you will get. So that is the minimum power guys. Is it clear, yes or no? Is it clear, yes or no? Is it clear now? Okay, so what is the correct answer guys? So in this question, the correct option is how much? So this is the wrong answer guys. Okay na? So this is the wrong method actually. Okay, and why we are not applying superposition directly, have you, I think you have understood. Okay, so this is not correct. So this is not correct. Is it clear na? So the correct option is 625. So option C is correct. Option C is correct. Option C is correct. Okay, so okay, so for you the task is what? For all of you the task is what? Just take as SW, or we can say just for your work, just try to solve this question. Okay, and take a screenshot of this. Just take a screenshot of this. Okay, and just take a screenshot of this and this also. Okay na? Just try to solve this question guys. Okay, so in next class we'll do all the theorems part. Okay, and after this we'll discuss transient part. Okay, in that only we'll discuss equipotential also. Okay na? So in that we'll deal equipotential guys. Okay, उसी में मैं बता दूंगा आपको. इज इट क्लियर रुपेश, है ना? तो उसी में मैं आपको ये भी बता दूंगा, क्योंकि उसके कंसेप्ट मैं बहुत बेसिक से ही बता दूंगा, फिर डायरेक्टली क्वेश्चन से एक से समझ में नहीं आएगा, तो ज्यादा बेटर है कि मैं उसको कंसेप्ट को ही पूरा डील कर दूं. ओके ओके, मैं उसका ड्यूरेशंस की भी बढ़ाऊंगा. कल से हम लोग कोशिश ये करेंगे थोड़ा क्वेश्चंस को भी फास्ट करें, बिकॉज टुडे इज द फर्स्ट सेशन. ओके, इसलिए मैंने स्पीड को थोड़ा सा बहुत कम रखा, और क्वेश्चंस भी हम लोग चाह रहे हैं ज़्यादा से ज़्यादा करें. अदर जरूरत होगी देन विल ट्राई कि उसके टाइम या फिर सेशंस को बढ़ाएं हम लोग. ओके ना, विल ट्राई फॉर दैट ऑल्सो. ओके, बट क्या है कि हम लोगों ने सब चीज़ों को लेकर कहा, मैं ये चाहता हूँ कि सेशन से जितने भी कंसेप्ट्स हैं नेटवर्क के वो आपसे कोई मिस ना हो, है ना, और इस तरह से समझें कि आपसे आगे क्वेश्चन ऐसा ना हो कि कोई फंसे और प्रॉब्लम हो. ओके, सो कल हम लोग इसमें जो डील करेंगे वो मैं बता दे रहा हूँ, है ना. सो फर्स्ट ऑफ ऑल विल डील व्हाट, सो हम लोग फर्स्ट ऑफ ऑल विल डील नेटवर्क थ्योरम्स, जिसमें कि हम लोग सारे जितने भी अच्छे क्वेश्चंस हैं, अच्छे कॉन्सेप्ट्स हैं उसको डील करेंगे. जिसमें कि हम लोग अभी स्टार्ट की बात करें, थेवेनिन्स की क्वेश्चंस देख रहे होंगे, थेवेनिन्स की बातें करेंगे, नॉर्टन्स की बातें करेंगे, मैक्सिमम पावर ट्रांसफर थ्योरम्स की बातें करेंगे. देन हम लोग रेसिप्रोसिटी की बातें करेंगे, रेसिप्रोसिटी से क्या एक अच्छा क्वेश्चन बन सकता है. देन विल हम लोग उसे भी डिस्कस करेंगे, है ना, विल डिस्कस दैट ऑल्सो. ओके ना. सेकेंड, आफ्टर दिस विल डिस्कस ट्रांजिएंट एनालिसिस ऑल्सो, है ना. और ट्रांजिएंट एनालिसिस के बारे में आपको पता होगा, इट इज वेरी 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 इंपॉर्टेंट टॉपिक फॉर नेटवर्क थ्योरी. ओके ना, इज इट क्लियर ना? या श्योर कृष्णा, या विल डू ऑल द थिंग्स, मैग्नेटिक कपलिंग ऑल्सो, इज इट ना? दैट्स व्हाई आई एम सेइंग ना. ट्रांजिएंट, आफ्टर ट्रांजिएंट विल डिस्कस व्हाट? आफ्टर ट्रांजिएंट विल डिस्कस टू पोर्ट एंड मैग्नेटिक कपलिंग, and will give you short trick for filters guys. Is it clear now? Short trick for filters also. Okay, will just what we have to do guys, you have to tell all the all the friend of you, है ना, or you can say just share all the session in your college group. Okay, and every day for you there is a session guys. Okay, and it is very very important for you guys. Okay, locus diagram is it for electrical na? Locus diagram is in electrical syllabus only. Okay, we'll take one or two questions for locus diagram only. Okay, locus diagram is very easy. Okay, we'll take that type of question also. Is it okay, Rupesh? Yeah, exactly. Yeah, so for electrical, exactly. Yeah, okay, है ना. So हम लोग करेंगे मैक्सिमम जितने भी पोर्शन हो सकेंगे पॉसिबल करेंगे, विल डू. Okay, okay, and just try to solve this question, guys. This one and this one. Okay, just try to find the answer. Okay, so we'll meet at 6 p.m. Okay, tomorrow. Okay na? Okay, guys, thank you, good night.